Alright, so we're going to go over a circle and we're going to look at its properties, going as far as the center and also how to determine the equation of a circle. This video is good for people who are doing analytical geometry, people that are studying mathematics in their second year in university, and maybe useful to somebody who is still in their first year and they're doing some conic sections. So let's just get into it. Okay, so this is actually, let me give you an example of a circle. So that's a circle, right? We understand what it is, but then at the end of this video you should be able to give a formal definition, mathematical definition of what a circle is. Okay, so let's try to analyze this and then we'll try to come up with some principles that would actually help us, right? Okay, so if you look at this circle, you can see that it's got a center in the middle there, right? Okay, so let's give it something. Let's say we'll say let our center, okay, so let's call that point center C. Let's call our center to be C. So given that our center is actually C with the coordinates h comma k, one thing that we can actually observe is that all these points on the circumference of course is this arc of the entire circle, so all these points to the center, they are of equal distance, and that equal distance is what we call the radius, right? I'm sure you agree with that. So if I was to draw a line, any line from any point on the circumference to the center is of equal distance, so we'll call that r, which is the radius. Okay, that's one thing that is actually basic to us. Okay, now what else do we know about a circle? Let's now continue our definition. So let's let our center C be equal to h comma k. Those are just coordinates, h representing x and then k representing our y for that coordinate. Okay, so let our center C be equal to h comma k, and then of course it should be a fixed point. So I'm giving you the formal definition. Let our center h comma k be a fixed point, then a locus. So a locus is just like a set of something. In this case, of course, mathematically we are talking about a locus of points, so a set of points. So what are we saying here? If we've got a center h comma k as a fixed point, then a locus, or think of this as a set. So when a set of points, what should these points be? These points should be of equal distance to the fixed point, right? So then a locus of points equidistant. So equidistant means equal distance. Okay, so there are a few things that are actually important here. First of all, the center should be fixed point. Then a locus of points, or a set of points, are equidistant, or of equal distance to a fixed point center, right? So equidistant from C. Okay, so this is what a circle is. So let our C, our center, okay, so let our center C be equal to h comma k, be a fixed point, then a locus of points equidistant from C is a circle. So if you've got a fixed point h comma k, a set of points that are of equal distance to this point is what actually forms a circle. Okay, I hope you get the formal definition. Something very simple, something very basic, right? Okay, let me help you try to remember. So the first thing just to remember is just try to draw a circle, right? Draw a circle. That's just the first thing that to do. It will be actually easy for you to, so let me just draw something that is not perfect. Okay, so one thing that you know is let that center of yours be h comma k, and then how can you use remember? So you just remember to say, okay, that point should be a fixed point, Then the set of all these points of the circumference, we use a fancy term, the locus of the points. Okay, now these points are what? Are of equal distance, so we use the term equidistant. Then you're good. So we just say let C, okay, so let the point C, of course we know is our center, h comma k, be a fixed point. Okay, that's very important, it should be a fixed point. Then what else do you add to that? So then you just add then the set, which of course we're saying the locus of points equidistant, okay, locus of points that are equidistant, okay, equidistant from what? From the point C is a circle. Okay, I hope you get it. So in other terms, you do actually say a circle is what? Is a locus. A circle is actually a locus of points equidistant from a fixed point C. Okay, so I hope we've gotten the definition now. Let's try to come up with some equations. Okay, so let me draw my perfect circle again, so that we can try to come up with some fancy equations, right, that are very useful. Now one thing that we know about this circle is we've already established to say we'll call our center to be C. Of course, we want the coordinates to be h comma k, commonly used as we study a circle, right? The other thing that we've established is we've established all these points on the circumference are of equidistant, so are of equal distance to the center C, right? Okay, we say the distance from the center to a circumference, to any point of the circumference, is called the radius. Okay, so if we're to find the radius in terms of a distance, of course we know the radius is like a distance, right? So the radius being the distance, and let's say any point on the circumference is x comma y, okay, and then we know of course our center is h comma k. So using our center to be h comma k, and then any point on the circumference can be x comma y. Using these two, we can easily come up with an equation, right? We understand this is just basic mathematics, basic geometry, coordinate geometry. We understand that if you've been given, or if you have 2 points, you can easily determine the distance. So the formula for determining the radius or the distance from the center to any point on the circumference, which we're calling the radius, is just basically using the coordinate geometry distance formula, where we've got 2 coordinates, right? So it's basically simple, right? The distance formula is given as the difference between these coordinates. So you start with a x minus, so in terms of our center, remember your h is representing x, your k is y, so that would be x minus h squared plus, and then y minus k as well, right, squared. We understand we're supposed to have a square root to that. Okay, we're supposed to add a square root to that. Okay, and there we are. So that is the formula for determining the distance, and so that is how you determine the radius, okay, of a circle. And this is now where the equation is going to come from. Easily just square both sides. Your r squared becomes, the square root would disappear on the right, and we just remain with x minus h squared plus y minus k squared. So if you've actually did your coordinate geometry, this shouldn't be a struggle for you to remember. Okay, just remember the basic distance equation. That is basically what gives you the formula for determining the length of the radius. Okay, and that is actually where the equation of the circle actually comes from. So these are the basics that I needed you to know before we can look at any basic example. I've got several practice questions, but for this video I'll just give you one, just register on our site. You have access to, the link is in the description below. You have access to several practice questions on this very topic. So let's try to answer with the basics that we've come up with so far. So we're asked to find the equation of a circle with a center at 2, -3, which passes through a given point. So this is just any random point on the circumference. Okay, so don't forget our center, we said, is h, k. Now in this case we've been told the center is 2, -3, and then the random point is just x, y, which in this case we are told is 5, -1. So we are told to find the equation of the circle. How do you go about that? Simple. So what is the formula for determining the radius? R is equal to the square root of what? So now in terms of it being squared, we say this r squared is equal to x minus h squared plus y minus k squared. Where is this coming from? It's just coming from the distance formula, right? Where you use these points against each other. So it's x minus h, y minus k, both squared, and then on the other side r is squared. So this formula applies whether they give you, whether they ask you to find the equation or they ask you to find the radius, you still use the same formula. So just substitute. So the first thing, first of all, is to determine the radius, which we will. So substituting the equation, what is our x? Our x is 5. Our h is what? 2. I hope you're able to see. Open your eyes. Y is -1 and our k is -3. So I have to be careful with the signs there. Our r squared becomes 5 minus 2 is 3 squared. And then negative times negative gives us a positive, so -1 plus 3, that's a 2, so that will be a 2 squared, which of course will be 9 plus 4, which will be 13. So r squared is equal to 13. Let me not erase that. So r squared is equal to 13. Okay, so for us to find the radius, we know r is just going to be what? 13, because we know the distance can't be a negative, so of course plus or minus 13 doesn't work. You just go for a positive result. So that is our radius. So we found our radius using the formula of the distance, and then we can actually use that to help us find the equation of a circle. How do you find the equation of a circle? Simple and straightforward, right? So we'll substitute our radius. Our radius is 13. Okay, so that is well, with something that I've messed up here. I hope your eyes were able to see. So okay, so the square root, we square root both sides at this point, and then r becomes plus or minus 13, but pick the positive result as default. So r is actually root of 13. Okay, so for us to find the equation of a circle, we just substitute back in this equation. We know our radius is the root of 13, which at the end of the day will just take us back to our r squared to be 13. And then now, as we come up with the equation, this point was just a point of reference, so we'll just use the center. Okay, so the x and the y will not appear in the equation, so x will remain as it is, and then we'll substitute our h is 2, so it will be minus 2 squared plus y, and then our k is -3, so -3 squared as well. The square of root 13 is just going to be 13, and then you're going to remain with x minus 2 squared plus y plus 3 squared. So you can actually end at this point. This is enough as an equation of a circle. Okay, but in some cases, most of the people want to actually go beyond, expand and whatnot, and just want to write the equation in the form where it gets to a point of like x squared plus y squared plus what, and then equal to 0. That's also fine. Okay, but for the sake of this video, I'll just end at this point. You can easily expand this as a quadratic equation, right? Even that part, combine them. Okay, let all of them be on one side and then equal to 0. Okay, so that's how you find the equation of a circle. Just hoping this was helpful. And the next question is a bit more interesting. Here you are requested to find the center of a circle. The equation is, so you've seen that the equation in this case has been given in an interesting form, which is 3x squared plus 3y squared plus 6x minus 4y minus 5 is equal to 0. Okay, so before I can answer this question, I want you to watch some more practice questions. The video is on our site. After you watch that video, you find the next video I'm going to handle this question. In fact, the similar questions have already been handled in the video, which is over 20 minutes long, of practice questions just on the circle. Okay, so if you are studying engineering mathematics or mathematics in second year in college, this is the suitable course for you. Okay, so these are the contents of this course. So analytic geometry, differential calculus, integration, finite series, vectors with 3 dimensions, functions of several variables, ordinary differential equations, matrices, linear system, and vector spaces. So all this has been covered in a course. The link is given in the description below. You want to tell your friends about it. This is going to be fun. We'll do a bit of some tutorial sheets, practice questions that will help you in your 2110 or whatever the course code is. It's supposed to be something that starts with a 2 if you're in second year. Okay. Alright, so this is where we end for this video. This question is very simple, and you wanna watch our solution on our site. Thank you very much for watching, and have a good day. Alright, so we are now going to answer this interesting question. Now, hoping that you've watched the video where we've dealt with several questions. So you've come across a question which is requiring you to determine the center and of course the radius. So I'll just add a few things here, and we see how we can handle this one. So a difference with other questions is this one has got some coefficients attached to x squared and y squared, which is of course a 3. So as you might guess, the first thing that we need to actually do is basically remove the 3. Okay, so how do you do that? So just divide throughout by 3 and then apply the same principle. So with that, pause the video and try it out. Okay, let me take it up, hoping you've tried it out. So divide by 3 throughout. We're going to remain with x squared plus y squared. The 6x to be divided by 3, that will give us a 2x. The other part, we're just going to have negative 4 over 3. No, yeah, we're dividing by a 3. And then 5 over 3 as well, equal to a 0. On the next step, what should we do? We need to collect the like terms. Okay, I'll begin with x squared. So we have x squared plus 2x, and then we'll move to the other part, that is now y squared minus 4 over 3y. The constant can be on the other side. Okay, I'm sure you have got an idea of where we're trying to take this. The form of the equation of a circle, r squared, which is radius, is equal to x minus h squared, right? Plus what? Y minus k squared. So that's the form that we're trying to lead to. So we're a bit closer, but still far. What do we do? Okay, so these are to be grouped, and we see now what we can do. So completing the square is actually the best way that we can move from such a form to a form where we can have a square. Okay, so let's try to just do that. Let me create some space. Okay, so what do we do here? We complete the square. So this is 2x. So what do we do to complete the square? Something very simple, right? X squared plus 2x. We just add the half of the coefficient. So what's the half of 2x? in terms of the coefficient, what's the half of 2? It's a 1, so add 1 squared. So now, to ensure that we are not changing the meaning of the equation, we can actually just add the same one, but we'll subtract it. So minus the 1 squared. The other alternative way is where you add it on the other side directly, which is the one that I'm going to apply. Okay, so plus, now we have y squared minus 4 over 3. So what's the half of 4 over 3? So 4 over 3, for you to determine the half, just multiply by half. That's going to be 4 over 6. Now the fact that it's negative, it's going to be negative 4 over 6 squared. To make things easier for ourselves, we can divide by 2 there. That's going to give us a 2. 2 into 6, that's going to give us a 3. So instead of having negative 4 over 6, we can just substitute. Though we'd actually end up with the same answer, but I want to work with the smallest numbers. Okay. So, and then that's equal to now 5 over 3. Now don't forget what we need to do. We've changed the form of the equation. We've affected the equation because we've introduced new terms to the left. So we should do the same to the right as well. So that is what I was trying to say. We could have subtracted like this. Well, we'll say, and then here also we can also subtract. But instead of doing that, we can actually move them directly to the other side where they will become positives. So add whatever we've added to the left should be added to the right as well. So that is, we'll add the 1 squared and then also the negative 2 over 3 squared. Okay. So on our next step now, we'll just pull out the middle part will be pulled out, and then we'll remain with x plus 1 for the square, plus the other part as well is going to become y minus that, and then we'll pull out the square, equal to 5 over 3 plus 1 squared is just a 1, negative 2 over 3 squared is going to give us a 4 over a 9. Okay, we're getting closer and closer, right? So at this point, actually, if the interest of a question is just that you give the center, even without the radius, you can actually even end. Okay, so this is what is going to give you the radius in the form where it is squared, r squared, and then this side is actually what is going to give you the center. So you can actually get the center from this point. So where you know this is h, that is k, and then the center is h comma k, right? So this just becomes, you have to change the signs, so that would be negative 1 comma positive 2 over 3. I've changed the signs. The reason is very simple. If you look at the equation, this is r squared is equal to x minus h, and then squared plus, and then y minus k, right? So you can actually see that whatever is in the bracket is a negative of the original, so we have to change the sign. Okay, so that's how you find the center. Just for sake of computations, you can actually simplify this. The common denominator is what? 9. In cases where you don't have enough time, just end at that point. That's okay. So 3 into 9 is 3 times 5. 3 times 5 is what? 15. 1 into 9, that's going to be 9, plus 9 into 9, that's 1, 4. So 9 into 9 is a 1, times 4 it's a 4. 15 plus 9 is going to be what? That's going to be 24 plus 4, 28. So what we end up with after simplifying will be something like 28, if my calculations are actually okay. 28 over a 9. Okay. So still the answer still just remains the same. Okay, so this is r squared. To find the radius, you can just determine the square root, right? Okay, so hoping our computations were okay, that should be give you the radius of that circle as well in case I ask you. So that's how simple this question was. Yeah. Aye. So I just wanted to let you know to say we have a longer video to this topic. The video also includes questions on conic sections. Okay, so this story sheet that you're seeing here, solutions are provided too, and then more questions on other topics covered, including the ones that have been covered in this video. Parameterization, power coordinates, and every concept of conic section is fully covered. Okay, so just head over to Hyperbola on our site. Links are provided for in the description below to build confidence and just get out of this simple topic. Alright, so in the start of our conic sections, we've already looked at a circle. Now we're going to talk about a parabola. Okay, so equally we're going to define what it is, but first of all, before we get to that, I just want to explain what it is in basic terms, and then we'll look at the formal definition, and then we'll move at coming up with the equations that are going to be useful. Okay, so don't look at my very perfect parabola. I don't think it's even perfect. Yeah, but the parabola is just something that can look like this. If you have to draw it, it can be like this, it can be like this, it can face our direction, it can also face downward like that. So an example of a simple parabola that you've come across already, I know, is a quadratic function. So a quadratic is actually a parabola. Okay, like that and like that. Okay, and that's exactly what we're going to get to define basically. So what are some of the few things that would help us establish what a parabola is? Okay, so let's think of a fixed point. Now a fixed point is going to be on the side where the parabola is opened. So we're going to call that point the focus. Okay, and then you can see I've put a line deliberately. So let's call this line the dielectrics. Okay, dielectrics. Okay, from the word direction. So we define a parabola in respect to these two. That is a fixed point. Okay, and then a dielectrics is a line on the other end, which is also a fixed line. Okay, so the basic principle that lies in a parabola is this: the distance of any point on the parabola, it may be this point, or it may be that point, it may be that point, it may be that point. Measuring any of these points, measuring the distance from the focus to that point, and then again from that point to the directrix, the distance should be the same. What am I trying to say? If you look at that point again, measuring to the focus, and then again measuring from that point to the directrix, the argument is this should be equal. And that's basically what the parabola is, just by focusing on the focus and then also looking at the dielectrics. So any arbitrary point on the parabola should actually be of equal distance to the focus and to the directrix. Okay, basically that's what the parabola is. Okay, so if we're to define it, before I get to talk about other things that you can actually identify, we have to talk about the vertex, the axis, the focal chord, the lattice rectum. So I'll tell you what those are. Let me just write for you the definition of what a parabola is based on what I've given you already. So basically a parabola can just be defined in basic terms to be, it's just a set, okay, of all points. So it's a set of all points, and of course these points you can see that they are x, y. So it's a set of all points in a plane, and these points are equidistant, implying equal distance from a fixed line. You can start with a point if you want. Of course, I'll put in the brackets this line. We say this what? Dielectrics. So if you combine all the points in a plane that are of equidistant from a fixed line called the dielectrics and a fixed point which is called what? The focus, right? In a plane. And it's very important to note that the focus is not on the dielectrics, it's elsewhere. It shouldn't be on the dielectrics. That's very important. So you can also add that, of course, not very important for now. So this is a definition of what a parabola is: a set of all points that are of equal distance from a fixed line called the dielectrics and a fixed point called the focus in the plane. Okay. So let me make it more interesting for you. Let's try to identify certain parts. Okay, let's come up with certain things on this diagram of ours. Okay. So I have to mention to say there is what we call the axis. Okay. Now before we talk about the axis, let me talk about the vertex. On the diagram, this central part of a parabola, we call it the vertex. Okay. So others define the vertex to be a midpoint between the focus and the dielectrics. Okay. Others, that's what they call it. But you can actually see whenever we've got a parabola like that point, in short, is what we're calling the vertex. Nothing special, nothing difficult about that. That's very basic for us to see. Okay. Now, from the idea that the vertex is the midpoint between the dielectrics and the focus, I need to point out to say the distance. Let's say the distance along the axis. So the axis is already clear whenever we talk about the x and the y axis, so you know what it is, right? So in that regard, we're going to define the axis as the line, of course, that joins the vertex, that passes through the vertex and the focus. That's what an axis is. So this same y-axis is an axis because it passes through the focus and the vertex. And then the distance from the vertex, this part, up to the focus, is called a directed distance. Okay, just so in case you know. Now the distance measuring from the vertex, this point, up to the focus, let's say the distance is p units. Okay. Now, implying that the vertex, knowing that the vertex is actually the midpoint between the focus and the directrix, then we would understand that even this distance is also going to be p units, but in the negative direction. So p units as well. Okay. Now, taking note of that, I can introduce another concept that you actually need to know. So if I was to increase my drawing of a parabola, okay, like that. So any line that passes through the focus and touches the parabola on 2 points is called the focal chord. Okay, so a focal chord is a line that passes through a focus and touches the parabola on 2 points. That's a focal chord. Okay. Now, there's a specific kind of a focal chord, specific type of a focal chord, which is unique because it's perpendicular. So that passes through the focus and then it's perpendicular, like that. That one has got a special name that we say latus lectum. Okay. This one is perpendicular, okay, to the axis. So it should be perpendicular in this case to the y-axis. So that is called the latus lectum. Now, something special about the latus lectum is if we try to assess the, remember I said if the distance from the vertex to the focus is p units, one thing that you need to know is if we try to assess the letter select term, this side is going to be 2p units and the other side 2p units as well, telling us to say the total distance of the letter select term is actually 4p units. So it's like 4 times the distance of from the vertex to the central part, right? That's one thing that you need to know there. Okay, 4 times the distance from the vertex to the focus. And then on the other end, I think these basics for now are enough. Given you the definition of giving you the basics now, I think it's now the time, it's time that we actually now did come up with our equation that is going to represent our parabola. Okay, so feel free to pause the video. I know some of these things you may not actually remember them just now, but with time, as you look at several questions, eventually all these terms will become familiar to you. Okay, so let me draw for you a parabola again. So let's draw a parabola. I want the vertex to be on the origin, so let me draw it like this. Okay, not perfect. So okay, we're just using it for demonstration. Okay, so don't forget your coordinate geometry because it's now going to get handy right now. So how do we move? So let's say we have our vertex is on the origin 0, 0. So let's call that M, and then let's put our focus somewhere there. So that's our focus, and then we'll get any point on the directrix. Let's call it D. Okay, so one principle, one definition that we've made so far, we've said if you get any point, but in this case I've decided to get the vertex. If you get any point, you can get any point actually like that. The two lines should be of equal distance. Okay, measuring from the focus and to the directrix as well, the distance is the same. Okay, for any arbitrary point on the parabola. So now let's get any arbitrary point on the parabola. We'll call it x comma y, and of course we've decided to pick specifically the origin, okay, which is of course 0, 0. Now we don't want to just use that because we want to make it general for any case, so that we come up with an equation that would apply for any case. That's why if you want, you can actually decide to get any point of your choice. Another example of a point you can get would be measuring from that to that point, and then like that. You can actually call this point to be maybe something like x comma maybe p, right? And then that one can be 0 comma p, and then on the bottom you also measure the come up with a point there. But I don't want to get to that. Let me just use this demonstration. What's important is we get the equation, okay, for our case. So let's use p units again as a distance from the vertex to the focus. So let's say p units. So I say the distance of the directrix as well going down will be same units, p units as well. Now if we're going to measure p units upwards, we understand the coordinate there of the focus is going to be 0 comma p, and then for directrix this point as well is going to be 0 comma negative p, because those are negative units going down. Okay, so now by definition the distance from that point on the parabola M to the focus, okay, so that distance, so I call it M F, that distance is supposed to be equivalent to the distance from the same point M again to the directrix on point D. This is what we say the parabola is. Okay, So now taking note of the coordinates that we have, what are the coordinates of m? We've said m is 0, 0. Okay. Now to ensure that it applies for every case that we can work with, we can just take it to be x, y, and then our f is 0, p. Then on the other end again, for m, we understand it's x, y, but since we just want to apply now the principle of want to use the concept of the origin to help us show the x and y to be present in our equation. So for the other side, we can actually just use 0, y. Okay, we'll decide to substitute the value of x because we're on the origin, and then of course for the d, it's 0, p. Okay, on the other side we've used both. Okay, it doesn't matter, you can exchange them, the equation will still end up to be the same. So I've used an arbitrary point, just x and y, and then on the other side I've decided to show the value of x. Okay, so how can we measure, how can we calculate the distance? This is now where I said you have to remember the formula for calculating the distance, which is very simple. Distance from coordinate geometry, if you're given 2 points, is just x2 minus x1, that being squared, plus again y2 minus y1, that also being squared, and then the square root of that. Okay, so we'll apply that same formula there. So these on the second ones will be the 2's. So we'll start with x. So we've got 0 there, we've got x, so that will be 0 minus x squared plus p minus y squared as well. Now square root of that should be equal to, on the other side we have 0 minus 0 squared, which is just nothing, and then go to the y, negative p minus y squared. Okay, so so a case where you've got a square root like this, you can actually just square both sides so that it can actually disappear. So the square root can actually disappear when you square both sides. Okay, so we're going to remain with 0 minus x squared, which is going to give us negative x squared, which is just going to be x squared, plus, and then remain with p minus y squared is equal to, that is just a 0, negative p minus y squared. Okay, and so what do we have now? So we have x squared, p minus y squared. You know how to expand that, so that's like p multiplied by p minus y, and then of course negative y multiplied by p minus y. So that will give us p squared minus 2py and plus y squared equal to p squared, and so we're applying the same concept as well. So negative p multiplied by negative p minus y, and then negative y multiplied by negative p minus y. So this will be p squared plus py plus py plus y squared. So that is going to be 2py plus y squared. Okay, we can now collect the like terms here at this point. So what do we have? So this and that can subtract because they are of the same sign. Equally the y squared are of the same sign, so they can equally subtract. So far we have x squared remaining on the right, on the left, and then this part as well, which can actually, we can add both sides, plus 2py plus 2py. On the left it will disappear, and then we're going to just have 4py on the right. Okay, I hope this equation now looks familiar. So this is actually the equation we're going to be using when it comes to the equation of a parabola. Okay, so you can see it's a quadratic equation that you're very familiar with, right? So can you remember the kind of parabola that we started with? So we started with a parabola that was actually facing upwards. Okay, you can call it a smile. Okay, so the equation for that parabola is actually x squared is equal to 4py. Okay, and as you might guess, if we're to flip it, the key point or the key understanding is the focus should always be on the open side. So if we're to flip it like this, the focus is going to be downwards there. Okay, now if we do flip it, the equation becomes what? X squared is equal to negative 4py. The idea is if the parabola has opened in the y direction, then it's x squared. You can actually remember this from quadratics, because you know what a quadratic is always upwards and downwards like this, and the equation is in the form of x squared plus something. It may be negative x squared. It's negative x squared when it's facing downwards. Okay, something like this, plus. It may be plus 2px or plus 2x, and then plus a constant in some cases. And then for the one facing upwards, it's going to be positive something like that. Okay, so that can easily help you remember the equation. So this is actually x squared is equal to 4py. This is x squared equals negative 4py. Now if it actually gets to face the unusual way directions like this, while the vertex is on the origin, as you might guess, the equation will be what? So instead of x squared, it's going to be y squared now is equal to 4px. So what we've done, we've swapped in the original equation where we said x squared is equal to 4py, we've swapped the y and what? And the x. Okay, it's also possible to have it face the other side, and if it does, equally it's negative 4px. Okay, so these are the forms of equation of a parabola that are going to be very useful, and I've explained to you the key things. You know what the axis is, you know what the vertex is, you know what the lectern is, you know what the focus is, you know what the directrix is. So now let's look at a simple basic question. We see if we're able to answer it. Okay, given y squared to be negative 8x, the question is would be find the vertex and then find the focus. Okay, and also the directrix. Okay, so what's the directrix? Pause the video and try out this question from the basics that I've given you. So the vertex I've already explained, the focus I've already explained. The focus is a fixed point, directrix is a fixed line. Okay, now first of all, when you look at this question, the first question you need to ask yourself is this going to be like this or like this? Okay, now y squared, an equation with y squared, it means it's facing in the what? In the x direction. So this should be something like this or like this. Now the fact that it's negative, it already gives an idea that it's going to face the other side like this, right? Okay, so what was the form of equation? So the form of equation was y squared is equal to 4px, right? So we just copied the other side. It's very easy. You just look at the left hand side, there's y squared, so you know what to put on the other side, it will be x, right? So now for you to make things easier for yourself, you want to find the p units. So x and x are the same, so we'll just equate the 4p. As we calculate, we're just going to say let our 4p be equated to, you can actually forget about the negative, because the negative is just telling us that it's going to be on the negative side. But of course you can actually maintain it if you want. Yeah, so that way our p is going to be, if you divide by 4, it's going to be -2. So our p is equal to -2. So the vertex is going to be simple. So our vertex is just going to be 0, 0. The fact that we can just see that it's actually matching up to the form of 4px. So our vertex is called 0, 0. So if that is our vertex, and then we've determined its the focus is always going to be on the open side. Okay, now looking at it, in this case it's facing the left side, so the focus is going to be on this side. Okay, so if I'm to show the axis, you can actually tell this is the x-axis. So how many units are we moving to the left? -2 units. So that's going to be at point -2. And then the same units to the right, so it will be +2. So the vertex is at 0, 0. The focus, which is always on the open side, is -2, 0. And then the dielectrics is going to be the line that's going to pass on this point. Okay, what is the equation of that line? Since it's cutting the x-axis, that is x is equal to 2. So this is the directrix, the vertex 0, 0, and this is the focus. Okay, simple and straightforward. What if I gave you another example? Let's say I said x squared is equal to +2y. What do you think? The fact that you can see x squared, you know that this is the basic quadratic equation, right? So you can actually just go on. You know it's going to be x squared in the form of 4py, and then equate your 4p to the 2, and then your p will become what? 1/2 when you divide 2 by the 4. Okay, so already this guy, the fact that this is in the y direction like this, so this is something like this. Okay, so you know the focus is going to be on the open side, right? So what do we do there? It will be 0, ½ units. So what is the focus? And then where is the directrix? The directrix now is going to be down there, -½ because the distance to the directrix and to the focus should be the same from the vertex. So that is going to be, the equation there is going to be y is equal to -½ as our directrix. So if we had to change the sign, you would guess what actually would happen, right? If we change the sign, we'll just flip it then. Okay, what changes? The focus now will be down, the directrix will be on top, so they'll swap. So therefore, in that case, the directrix, which is the line, becomes half, and then the focus would be on 0, -½ Okay, so hopefully this video has given you a good background, a good introduction to what parabolas are. And of course, I'll add a video just below this one where we're going to look at some more questions that are going to help you build a strong foundation on the parabolas and of course other conic sections. Okay, otherwise we'll move now to hyperbolas. Alright, so in our study of conic sections, I'm now going to move to a hyperbola. Okay, so if you look at the entire diagram that you're looking at right now, this whole thing is called the hyperbola. Forget about the triangle that is inside. This is just there as an aid to help you understand what I'll explain. Okay, but instead think of a hyperbola to be something that looks like this. Okay, kind of like a set of two parabolas, okay, that are facing in opposite directions. This is what a hyperbola is. Now what defines a hyperbola is the fact that if you try to measure any point on the hyperbola, let's say we take that point, an arbitrary point, let's call it P, which is x comma y, and then we come up with two fixed points, let's call them f1 and f2 from each parabola, and then these are two fixed points. So the definition of what a hyperbola is the difference from P to f1 and again from P to f2. So let's call them distance 1 and then distance 2. Okay, so the absolute value of the difference between d1 and d2, okay, is a constant. Okay, that's basically the basic definition of what a hyperbola is. So if I'm to get another point on the hyperbola and then again measure its distance from f1 and then again to f2, again its difference, okay, if you're going to call it d3, d4, again the difference between the two distances is going to be a constant. Okay, that's basically what a hyperbola is. Now a few things that will make it more interesting is we have to understand a few things here. Okay, so let me try to redraw it again and then we try to come up with a few names. Okay, that's not too perfect. Let me just use this. Okay, well, it looks too complicated. I'll just have to draw something for myself again, like that. Okay, so first of all, to start with, there is what we call a transverse axis. So a transverse axis is a line that cuts the two fixed points we called f1 and f2. That's what a transverse axis is. So it cuts the 2 points. Okay, so that's what the transverse axis is. So the other thing you can actually notice is that actually also cuts the vertices. It cuts the hyperbola at its two vertices, right? Okay, you know what a vertex is from a parabola, right? These bottom parts. So a transverse axis passes through the foci. By foci I mean the two fixed points. So when it joins the 2 points, it also cuts the hyperbola at two of its vertices. That's one thing that you can note. Now the midpoint of the transverse axis, which can also be called the focal axis, its midpoint is known as the center of the hyperbola. Okay, that's very important as well. Now of course the hyperbola has got asymptotes which cut it through the center. It has got two asymptotes that may be like that. These ones are very key when it comes to drawing a hyperbola because you can just draw them and then just know that these can never cut or meet with a hyperbola at any particular point. Okay, so I'm here to give you the full written definition, but I was just trying to give you the basics of what you need to know. Okay, so from that we can now come up with a full definition written down. I'll give you two, whichever you find simple. So this is just describing what I've already explained. So the set of all points, okay, so a set of all points for which the absolute value, okay, for which absolute value of the distances or the difference between the distances from the two fixed points. f1 and f2, which can be called the foci, is a constant. So a set of all points for which the absolute value of a difference between the distances from the two fixed points f1 and f2, which are collectively called the foci, is a constant. That's one way we can actually define it. Very simple, right? I'm just describing what we're trying to say. The other way would be, you can just say the locus of all points. Okay, you can think of a locus as a set, so such that all, or how can I put, okay, such that the difference, so the locus of all points such that the difference, okay, of its distances, so a difference of its distances from what? So from the fixed points f1 and f2, collectively called the foci, is a constant. So that would be a basic definition of what a hyperbola is. Okay, now using this diagram here, this is just a summary of what I've talked about. So far, I've said there are two asymptotes that actually meet at the center. The center is the midpoint of the transverse axis, which cuts the foci f1 and f2. Okay, so the transverse axis also cuts the vertices. I did mention that. And then I said this is actually a demonstration of, again, what a hyperbola is. Measuring of distance from f1 to p, and then again from f2 to p. So call that d1, call this d2. The absolute value of their difference is what gives you a constant. So it doesn't matter what point you pick, and that's what the set of such points is what actually define a hyperbola. It can be the same, you can measure it from the other side as well. Doesn't really matter. Okay, so let's move on now and talk about and drive the equation of a hyperbola that will help us be able to determine the vertices and be able to determine the foci, that's f1 and f2 when asked, and also be able to determine the equation of asymptotes when you're also asked. Okay, so let's just do that. Alright, so I've already introduced what a hyperbola is to you, and you understand that basically what a hyperbola is, we've got two parabolas that are kind of like a reflection of each other, right? And using a perfect diagram, this is what we have. I did emphasize the things that we have. We've got the center, where we've got two asymptotes intersecting, and then we said the basic definition of what a hyperbola is. We said this is where, if you look at the distance from the 2 points that we collectively call the foci. So if you try to subtract or find the difference between the two distances from any given point on the hyperbola, for example, if you focus on a point P, okay, if you measure the distance from f1 to the point P, and then you subtract with the distance from, again, the point P to f2, okay, of course the moduli of these, find their difference, they're going to give you a constant, right? So now it doesn't matter if you get another point again on the hyperbola, or from there again measure the distance to f1 and whatnot, you find that you're always going to be getting a constant there. That's very key and basic for you to understand. Now in this video I want you to pay attention to the variables a and c. Okay, so if you look at a is a distance from the center to the vertex, right, to the vertex of the vertices, okay, of the hyperbola. So that point and that point, measuring from the center, the distance is a. Now c is a distance up to the foci on both ends. Okay, that's one thing that you have to understand. Now paying attention to that, I want you now to get the equation. In this video I'm not going to go over how we can actually come up with a formula and whatnot. I'm just going to give you the formula, and then we'll look at how we derive the formula in another video. Okay, So now let's pay attention. The equation is as simple as x squared over a squared minus y squared over b squared. And of course this applies when your transverse axis is horizontal, like in this case. This is equal to a 1. Now you're already asking a question to say where is the b squared, where is the b of the variable b coming from, because if you look at the diagram that we have, we only have a and c. So I want you to know that the b squared is actually representing the difference between c squared and what? And a squared. Okay. Basically, it was just a substitution. That's why if we look at the video where we are going to derive, you see that b is just something that we just come up with to easily help us remember the equation, right? I think this equation is very simple for us to remember. Let me take you over it again. So the fact that you have x, y, a, b, and then just put the difference and then square them. Simple, right? And then this is equal to 1. Okay, so that's the equation. I hope it has gotten, we've removed it now from our way. We understand what it is. So on the other hand, where you have your transverse axis to be horizontal, in what I've drawn, we just do the opposite, right? So in this case, what do we say about the equation? It will be the opposite. Now we start with y. So y squared over, but what's on the denominator doesn't change. We just swap y squared and x squared. Again, equal to 1. So we know the equations now. You are easily able to remember the equations, okay, that are associated with a hyperbola. Okay. So now let's look at a sample question. In fact, before I go over that, I think there is an aspect that is also key and important. The asymptotes. So they may ask you to determine the equations of asymptotes. So yeah, let me give you an example. So let's assume our center is 0, 0. Okay, and then let's assume the distance. In fact, let's try to come up with a rectangle just here. This rectangle of ours should cut the vertex like that. Even on this other side, and then draw a line like that. Okay, so now assume now the distance from the center going to the left, the vertex. Remember we've said that's a, right? So on this side, if we measure the distance from the center up to that point, that would be negative a. The other side, that is going to be positive a. Okay, that's something that is very basic for us to understand there. Okay, and then we can come up with another variable b, which will now be the distance, measuring the distance in the y. So going up, let's say it's positive b up to that point. Going down, let's say that is point negative b, okay, along the y-axis. So when you get these points, if you look at that coordinate, that's going to be negative a, comma b. If you get this point, that's going to be positive a, comma negative b. So as a smart student, I'm sure you know how to find the equation of a line. It's in the form of y mx plus c, and you can easily find it, right? So the key thing is we need to find the gradient there. The gradient is y2 minus y1 and whatnot. Okay, change in y divided by the change in x attached to x will give us the first part plus our constant c. Okay, Now for our lines actually that cut through the center, for the C we're just going to have a 0, so no need of us wasting a lot of time there. So if we try to subtract any that we have, if we try to focus on the one that is along the one that's moving from left to right, sloping down, our y2, let's say our y2 is negative b, minus our y1 which is b, and then again we divide by the x. We have our a minus negative a. Okay, what are we going to have? So on top we're going to have negative 2b, on the bottom we're going to have a positive 2a, right? So we have a positive 2a there, and so what you end up remaining with is, that's going to be 2 divide, so you just have negative b over a. If you apply the same principle on this other axis that is sloping upwards, this one is going to be positive b over a. So therefore, in summary, what we're trying to say is the equation for the asymptotes is plus or minus b over a, where the slope going this way is positive b over a, the other one is negative b over a. Those are the equations that will help you determine the asymptotes, right? Okay, so that out of our way, let's now go over an example, a very detailed example that's going to help us apply the things that we've gone through. Okay, so let's assume you've been given 4x squared minus y squared and then is equal to 16. Okay, so the question here is find the foci, so those 2 points f1 and f2, and then the center and the vertices. Okay, so feel free to pause the video and just try out this question, right? A very basic question. Okay, so let me just go over it and just answer for you. Okay, so to start with, we understand that the form of the equation already, as we can see, is y squared. No, this is started with x squared. So this is x squared over a squared minus y squared over b squared should be equal to a 1. Now if we analyze this equation, whenever you start, I like thinking of it in this way. Whenever you start with, or whenever you move in the ascending order of both the x and y and then a and b, this is the horizontal transverse axis. This is the normal way. I like thinking of this as the normal way. And then if you swap and start with y squared, then you understand what you're expecting is going to be a vertical transverse axis, right? Okay, so let's now take the given equation in the form, in the basic form. So the basic principle is we need to have a constant of a 1 on the right. So how do we do that to what we have on top? So we have to divide by 16, right? So divide by 16 if we can have a 1 on the right. Okay, so I'll bring back that equation. For now, let's divide by 16. So what are we going to end up with? We're going to remain with x squared. 4 there, it's 1. 4 into 16 is 4 times. Minus y squared over 16 is equal to 1. Now we have it in the form of the basic form of the equation. Don't forget this is x squared over a squared minus y squared over b squared equal to 1. So our a squared, we can clearly see that is equal to a 4. They are on the same position. So if we try to find our a, we're going to find plus or minus 2, right, for a. And then for our b squared is equal to 16. Now remember I said your b squared is the same as c squared minus a squared, right? So our b squared, we understand, is matching up with 16. So we're going to have 16 is equal to c squared minus a squared. Our a, whether taken as positive or negative, it is still going to end up positive after we square it. Okay, so ideally a squared in itself is just equal to 4, as we can see. So we'll just put the 4 directly, and then our goal is to find the constant c. So collect the like terms. This is equal to c squared, so c becomes 16 plus 4 is 20, so the square root of 20. So we found our c now. Our c is the root of 20. I think with the confidence that we have at this point, I think if you paid attention to my explanation of the diagram that we had before, this is what we said. This is the center. The distance from here to the vertex, which is the shorter one, is a. Okay, on the other side it will be negative a, of course, when the center, if the center is the origin. Of course, the longer distance is going to the foci, right? Okay, which is the distance c. Okay, so to give the coordinates for the vertices, which is the shorter distance along the x-axis, so we understand along the x-axis the y-coordinate is a 0. So the shorter distance, which is a, is -2 and 2. So those are the coordinates for the vertices, the point where we're going to have the hyperbola like that. So for the vertices, we have -2, 0 and 2, 0. For the foci, that's where we use now c, so it will be plus root of 20, 0 and -0. The center is of course the origin, 0, 0. Finding the equations now. How do you find the equation of asymptotes? Remember we said our equation is in the form of plus or minus b over a, right? Okay, so in this case, what have we said about our b? Our b is 16. 16 is equal to b squared. B squared is equal to 16. So our b in itself is going to be plus or minus 4. Now we understand that for the asymptote that's sloping like this, it's positive, this one negative. So we're going to have 4 over our a, which we found to be 2. Now of course we understand for this case, we just have to be smart about it. For the slope, one is supposed to be positive, one is supposed to be negative. So we'll just say plus or minus, and then we end up with 2. So 1 is, now don't forget there's an x there to the equation. So 1 is 2x, the other one is -2x. These are the equations of our asymptotes for this question, right? Yeah. So I just wanted to let you know to say we have a longer video to this topic. The video also includes questions on conic sections. Okay, so this story sheet that you're seeing here, solutions are provided too, and then more questions on other topics covered, including the ones that have been covered in this video. Parameterization, power coordinates, and every concept of conic section is fully covered. Okay, so just head over to Hyperbola on our site. Links are provided for in the description below to build confidence and just get out of this simple topic. In this video, we're just going to look at what an ellipse is. We've already looked at the other 3 conic sections, the circle, the hyperbola, and then the parabola as well. So I want to talk about an ellipse. What is an ellipse? So in plain terms, look at F1 and F2. This looks similar to a circle, right? But we understand that a circle is where the distance from a point called the center is the same. Okay, so if I was to draw a circle here, in fact, let me just draw one for the sake of our demonstration. I will bring a compass just there, and then we'll draw our circle. Okay, so let me just do that for us. Okay, so that's what a circle is. When you compare this against what we have as an ellipse, there's a difference. So the distance from that point called the center to any point on a circle is the same, and we call that the radius. Okay, so this is different. Now when you look at the ellipse, the distance from the center to that point, and then again the distance from this point to that point, we can clearly see that there is actually a difference, right? Okay, so there is a difference. So the major axis and the minor axis are, we can actually see that it extends differently. So what then defines an ellipse? So an ellipse is defined by the property that if you look at the 2 points that we are calling the foci, okay, because there are 2 focus points, so the foci, when you look at f1 and f2, the distance to any point on the ellipse, the sum of the distances is actually a constant. What that implies is, if you look at P itself in this case, that point there on an ellipse, measuring a distance to f1, we call it d1, and then also we look at distance to f2, we call it d2. The sum is a constant. That principle applies to any point on an ellipse. So again, if we come up with another point, let's say this point, and then we measure to f1 and then again measure to f2, okay, by definition that is also equally going to be a distance. If we are to actually call it d3, d4, so d3 plus d4 equally would also be equal to the constant. That's basically what an ellipse is. Okay, so plainly I've actually written down for you to say a set of all points in the plane whose the sum of the distances to the points f1 and f2 is a constant. So this is another form of a definition: a set of all points in the plane, the sum of whose distances from 2 fixed points is a constant. Okay, now if I take you back to this diagram, I want you to know that a line that passes through f1 and f2 is called the focal axis. Now the focal axis cuts the ellipse on 2 points, okay, on 2 points that we call the vertices. Okay, that's one thing. So I'm calling that the focal axis. Okay, so the focal axis passes through the 2 let me say the foci. It passes through the foci and then intersects the ellipse at 2 points. Now the funny part is now where we again talk about a line again that cuts through like that. We call it the major axis, okay, because we have now what we're also going to call the minor axis. Okay, so the longer one is the major axis, the shorter one is the minor. Okay, so it's possible to have an ellipse that is actually in this direction, where the major axis is the y-axis and then the minor is the x-axis. That's also possible. Now that we understand what an ellipse is, we want now to come up with the equation that we're going to be using when it comes to an ellipse. Alright, so in this video we want to look at just 2 questions under the ellipses, and yeah, these are the 2 questions. One where we are told to find the foci, the vertices, and sketch, and then the one where they've given us the foci and the vertices, and then we're asked to find the equation. So we'll start with question 1. Find the foci vertices and sketch each of the following. Okay, one thing that you actually need to understand each single time is about the equation. First of all, whenever you see additions, just know that if you've not specified the conic section, know that you're dealing with the ellipse. Okay, and then if it's a minus, know that you're dealing with hyperbola, right? Okay, I hope that's clear. Okay, so now each time ensure that they're in the form of x squared plus x squared over a squared plus y squared over b squared is equal to a 1. So for the first one, you can actually see that it's not in that form, so we have to put it in that form, right? Okay. Then the other thing that you actually need to note is when you look at x squared over a squared plus y squared over b squared is equal to 1. It's very key and important to understand that when you are writing it in this form, whatever you are going to start with is the one that is having a greater value or a greater denominator. What that tells us is if it's in this form, a should be greater than b. Okay, so that this is this is actually going to be do you some good, because this will help you remember to say if I've got x squared having a greater denominator, then I'm dealing with an ellipse that is the major axis is along the x-axis. And then in a case where if y squared is having a greater value or denominator, you start with y squared like that. Then you know, again, you'll be able to tell by the number that is down there that actually what I have is the major axis along the y-axis. That's going to do you some good. So always write it, start with one that is having a bigger denominator so that you're able to tell. If you're starting with x, it's along the x-axis. If you're starting with y, like that. Okay, I hope that's clear. So we can actually, one thing that we know is we need to have a 1 as the constant on the right, so we can actually just divide by 144. Okay, so of course 144 by 144 is actually a 1. Now 144, if you divide by 16, that's 9 times, so we have 9y squared. No, so that's going to be y squared. 16 into 144 is 9 times, equal to 1. And then of course if you divide again 144 by the 9, it's going to give you 16, right? 144 divided by 9, so x squared over 16. Okay, so this is what I was talking about. Now in this case we can see that 16 is of course greater than 9, so we'll leave it in that form. Now how do we distinguish with a b? This is where you have to be smart about it. Okay, that's what I was saying now. So for the sake of our b, it's advisable that you start with y squared. That's me advising you so that you are able to tell to say that's going to be along the y-axis. The major axis is going to be along the y-axis. Okay, so now that you get that point, we've come up with our equation and we can easily pick it up from here. Now one thing that we said is the basic form of the equation is x squared over a squared plus y squared divided by b squared equal to a 1. So we can find our value of a. So a squared is equal to 16. So a is equal to plus or minus root of 16, which is going to be a 4. And then we can also find our b squared, Now b squared, of course, which we know when we are talking about an ellipse, it's a squared minus c squared. Okay, so therefore if our b squared is now in this case of course 9, and then of course b squared is 9, yeah. And then our a squared is 16 minus c squared. Okay, so c squared becomes 16 minus 9, and then c squared becomes 7, so c becomes plus or minus root of 7. Okay, so what did I say? Said the major axis is along the x-axis if x is one that is having a greater denominator, right? So therefore this is going to be something like this. Okay, if that's a center, okay, point of intersection with the minor axis, and then we've got the foci, of course, which should be inside. Okay, so since the foci is actually the shorter one, now the question that you need to ask yourself, between 4 and root of 7, which one is smaller? Of course root of 7, right? So that's going to be negative root of 7 comma 0, and then positive root of 7 comma 0. That's what are the foci. So the foci, if the major axis is along the x-axis, is given by plus or minus c comma 0. Then for the vertices, going to get the bigger values, so negative 4 comma 0, and then 4 comma 0. Okay, and of course it might interest you that b actually represents the value of the values along the minor axis. So the vertices on the minor axis are going to be positive 3 and negative 3, which actually implies 0 comma negative 3 and then 0 comma positive 3. So which implies the vertices along the y-axis on the minor axis is going to be 0 comma plus or minus b. These are the vertices. So that's how you come up with the ellipse there. Now hopefully you've gotten some of the things that I've said. Found the foci and the vertices. So now this other one, what do we do? How do we handle that one? Please feel free to pause the video and try it out. Okay, so like I said, start with the one that is having a greater denominator, in this case 16 plus x squared over 9, and then that's equal to 1. Okay, so in this case, whenever you start with y squared, you understand that the ellipse is going to be along the y-axis, the major axis is going to be the y-axis, and then the minor will be along the x-axis. Okay, so simple and straightforward, right? So y squared over a squared plus x squared over b squared is equal to 1. Our a squared in this case is equal to 16. Our b squared in this case is equal to 9. So our a squared, or our a becomes plus or minus 4. Now we understand that our b squared is actually equal to a squared minus c squared. So since we know that our b squared is 9, our a squared is 16, we can easily find our c squared, which of course is still going to be plus or minus the root of 7. Okay, and then we found a, b, and c, right? So our b is plus or minus 3. Now don't forget, this is going to be along the y-axis, so we have to put the foci inside. So the foci is going to be a smaller value if you compare a and c. So of course root of 7, and negative root of 7. And then the bigger values are 4 and 4. So something like this. Don't mind my drawing. It's kind of difficult to draw on the laptop. Okay, something like that though. Okay, so that's 4. This is negative 4. So we have 0 plus or minus 4 for our vertices, and then for the foci we have 0 comma plus or minus root of 7, and then of course for the minor axis, the vertices there, we're going to have negative 3 and positive 3. Okay, so hopefully I've given you a way that can help you remember the equation for the ellipse, and you're able to handle the questions with confidence. And of course, when you look at the tutorial sheet, I think you'll be able to handle the questions with confidence. Alright, so I've drawn again the axes. Okay, so a point that I was trying to get to in simple terms is this. This point, think of this point P. Okay, so I said if this point is x comma y, and then we decide to move it to that point, to the new point P prime, for example. If we've moved the center in the x-axis to be maybe h times, and then the y-axis to be k times, the new coordinate there would be what? So to add x would add h, and then to our y we'll add our k, right? That's if we are moving from the origin to the other way. Okay, now the way we move for our equation is we actually do the opposite now. So you find that the original shape is going to exist on the top part, on the other axis, right? So on the other axis, so that would be x comma y, measured in reference to the original xy plane. Okay, so given that the center of that point is h comma k, how do we find how do we reverse it and take it back to the form of the origin? So if we're to take it back to the form of the origin, I can use a point there for reference, P prime, and then to be x prime comma y prime. So what do you think would be what do you think is going to happen there? If going the other way we are adding, this other back we are supposed to do what? Subtract. So that can be written as, if we are to find the x prime, if we're moving from x there, since we are moving to the left h times, that's going to be what? So that's going to be the original x reduced by h, and then the y reduced by the k value. Okay, this is where now the relation comes in. Okay, if you are moving from a conic section that is away from the origin, now you're trying to bring it back to the origin so that you're able to write it in the form that is easily understood. You do the subtraction like that, and this is where the relationship comes in, where you say the new x coordinate is equal to x minus h, the new y coordinate is y minus k, can be expressed in that form. Okay, so that in our understanding, since we've brought back now the coordinate that was a bit up, we've brought it back to the origin. Okay, if we bring it back to the origin, we know the equations of the origins are simple. Now in this case, one thing that I have to mention again is, if you've paid attention, the way I've put the coordinates for about the origin, the origin one is away. Now I've brought it back to the origin. I've written it in the form of x prime and y prime, right? Okay, that's what I've done there. So implying that if we are to write the original equation for this circle, for example, So I will just instead use a parabola. So if I was to write equation for a parabola, let's say maybe instead of a circle, we had a parabola about this point, like this. Okay, what would we expect? So since we are using the x and y prime, because originally the parabola itself, we've moved it away somewhere on top there. Now we were bringing it back to the origin. So the equation would be, for this parabola which is about the origin, the equation would be x prime squared is equal to 4p y prime. Okay, and now if you try to substitute now what we have, that's now where this form comes from, x minus h squared, and then is equal to 4p y prime is y minus k. I just hope I haven't taken too long to just get to this point, and that's the argument that I've been trying to make all along. Okay, that's what translation actually involves. Now the key point of this topic is you should be able to move these ones in the form of any of the conic sections basic form of the equation. So now let me give you the full forms of all the conic sections in this form. Remember what we've got into. We've said our x prime is equal to x minus y, our y prime is equal to at x minus y, no, that's not x minus y, x prime is equal to x minus h, y prime is equal to y minus k, right? Okay. So for the parabola, I've already given an example. For the one that is facing upwards, or maybe along the vertical axis, this is something like that. So from that form, it now becomes x minus h squared is equal to 4p and then y minus k. So in other terms, the other original equations that we had, you just have to substitute now x minus h and y minus k. So of course for the other form, you might guess that it would be in that very form. So just a little exercise here. Well, how do you come up? What's the equation of the hyperbola? Can you remember? Okay, so hopefully you have remembered. The parabola is going to be, of course, what's a hyperbola? You think of it, this is something that is like this, and you can have x prime squared over a squared, and then here we look at the difference, right? And then y prime squared over b squared is equal to 1. So the full form is going to now be x minus h squared over a squared minus y minus k squared over b squared, of course, equal to a 1. Okay, of course this is a case where the focal axis is along what? Is along the x-axis. Now of course if it's something that's like this, vertical, you expect, of course, you start with y squared, right? Okay. And then for an ellipse, how do you expect an ellipse to be? So an ellipse deals with a sum, and that's something that can easily help you remember the equation. So in a case where the ellipse is the major axis is along the x-axis, you have to start with x prime squared over a squared. Of course, this implies a squared is going to be greater than b squared. Okay, equal to 1. So what do you have in this case? You've got x minus h squared over a squared plus y minus k squared over b squared equal to 1. Okay, so basically I've given you a full form of all the equations that you actually need to work with when you're dealing with translation. Okay, so now our next job is, are we able to transform these equations in these forms that I've given you here? That's what we need to look at now. Alright, so now that we've looked at the forms of the equations in the form of x minus h and y minus k, now are we able to convert these equations into that form? Okay, so I'll do these two examples, and then your exercise will be to do these three here. Okay, so the question may be phrased as this one is phrased. You may be asked to transform the equations into the standard forms and then identify it and graph it, or it may just be as plain as discuss the conic sections. Okay, so or even just graph or give the basic form of the equation. Okay, so how do we convert this? Because if you look at this, you can't tell whether it's a parabola, you can't tell whether it's a hyperbola, you can't tell whether it's an ellipse. So how do you get to know now? That's what we're trying to do here. Okay, so in each case, each time, complete the square. Complete the square. Okay, so let me group the y part since we only have 1x squared, right? So 2x squared minus y squared plus 6y is equal to 3. Okay, so at this point we can have 2x squared. Let me pull out the negative here so that things can move faster. So y squared minus 6y, I've just put out the negative, is equal to 3. How do you complete the square? Okay, how do you complete the square? You understand what we do when completing the square, right? So we're going to have, what's the half of negative 6? The half of negative 6 is actually a minus 3, right? Okay, that's what we're going to have. So 2x squared minus y squared minus 6y. If you want, you can even complete it in a separate paper, but I'll just do it from here. Half of minus 6y, or the coefficient of minus 6 is negative 3, so that squared. Okay, and then I'm supposed to add the other one on the other side, so plus and then that would be a minus 3, which is squared, right? Okay, and then what do we have now? We have 2x squared minus there's one thing that is strange here, so we put out a negative there. Okay, so that negative is going to affect this part, so let's complete the square from one end instead of what I've done. Okay, so one way that we can actually complete the square from one side would be to, since we know if we were to add it the other side, we're supposed to add it the way we have, and we've done it. Now one way we can do it from one side is we can introduce a new bracket there, and then that's we cross the other bracket from there, and then since whatever you add to the left should be added to the right, so to completing the square, since we've added inside there, if it was the other side, it was also going to be added. Now that is going to be on the same side, it's supposed to be a minus, so minus negative 3 squared, okay, equal to 3. So we've maintained this 3. This is just basic, don't overthink it. This is just basic completing the square. If I wanted, I would have just taken it the other side directly by just multiplying by that negative which is outside. Okay, so we have 2x squared minus, so after completing the square, now in the brackets we're going to have just the ones that are having a square, so y minus 3 squared minus our 9 there. We've completed the square. That's basic completing the square. Okay, and then we have 2x squared, distribute the negative, we're going to have minus y minus 3 squared, and then plus a 9 equal to 3. So we have 2x squared minus y minus 3 squared, and then is equal to 3 minus 9. Okay, what do we end up with? So we're going to end up with 2x squared, right? 2x squared minus y minus 3 squared and then is equal to negative 6. So if you think of the form of the ellipses, the hyperbolas, the parabolas, find that they're in the form of x squared over a squared plus maybe plus or minus y squared over b squared. Okay, and so you might guess what to do there. Since all these are always equated to 1, so for us to have a 1, what do? We have to divide by a negative 6, right? So negative 6, negative 6, negative 6. What do you end up with after dividing by negative 6? So we're going to have negative x squared over 3. This will become positive y minus 3 squared, since we are dividing negative by negative, so it becomes positive, and then this is just going to be a 1. So preferably we can start with y minus 3 squared over 6 minus x squared over 3 equal to 1. So now what comes to your mind when you see a negative in between there? Is it an ellipse? Is it a hyperbola? Is it a parabola? What comes to your mind? So think of a difference. Whenever we're talking about the difference, what do we talk about? It's a hyperbola, right? Okay. So, and in a case where we are starting with y, what do you think of? So it should be something that is like this. Okay. Now that we've reached the point where we've converted it to a standard form, okay, we've converted to this form now. Now the question is, are we able to state what the vertices are, what the foci is, and what not? Okay, so if we are to make an assumption, because we've already observed that this is a hyperbola, right? So we can write it in the form of y prime, since we're trying to move it to the new coordinate system. So y prime squared over a squared, and then minus x prime squared over b squared. This is equal to 1. Now if that is the form, we know that our a squared, what have we put? So we'll put 6 and then we'll put 3 there, just matching up with this. So the only thing that we've actually changed is the top part, where we don't want to deal with this new form already. We want to assume we're having the original form. Okay, now are we able to use our a, our b, and our c to help us find the foci, the vertices, and whatnot? So when you have a hyperbola like this, okay, the question that you need to ask yourself is which one is the longer distance? Is it to the vertices or to the inner points, the foci? So of course the foci is further away from this point, so the bigger value will of course represent the foci, and the shorter value will represent the vertices, right? That's the key there.
Charge my phone.
You can connect.
You sure? Man, I tried sleeping, but I can't sleep. I need to use my phone.
Oh, you I'm making a video. can charge your phone.
Maths video. When I said,
It's just going to confuse you.
I'm just gonna listen. I'm not gonna say. Not allowed.
Hmm?
It's confidential.
You can come and see the product afterwards.
Let me sit for 5 minutes. Are you just do the maths? Shh.
Okay, so our a squared in the original form is matching up with 6, and then our b squared is matching up with our 3 there. So therefore, if we try to find a squared is going to be equated to 6, which will give us plus or minus root of 6. And then if we try to find our b squared becomes equal to 3, which will give us plus or minus the root of 3. Now I've given you a hint to say if you try to look at a hyperbola, you see that what's actually closer are the vertices compared to the foci. So therefore, the shorter ones is going to present the vertices. But then you have to get back and remember what we did earlier when we started this topic. Okay? So I said if you look at the hyperbola, the b squared is actually a difference between c squared and your a squared. So now since your b squared in this case is 3, substitute your c squared is 6. We can try to find our a now, because we can't use a and b to as a distance, because in terms of a distance here we are using a and c. Okay, so therefore let's try to find how is it the value of a that is not there. So b squared is 3, a squared is 6, so c squared will still remain there, and then our a squared will be 6, and then c squared is going to be 3 plus 6, which will give us c squared is equal to 9, and then c itself is going to be plus or minus 3. Okay, so don't forget, b squared just represents c squared minus a squared, and when it comes to measuring the distance to the vertices and the distance to the foci, we use a and c and not the b squared that appears in the equation there. And so that will assist us to indicate what the vertices are. So now what do you think are the vertices? Now don't forget that this hyperbola, the fact that we have the y squared coming first because of that negative, what do you understand? So we've said it's along vertical y-axis, okay, like that. So we expect these coordinates to represent the y part of the axis. So the foci which are far are going to get the bigger values. So for the foci, we're going to have plus or minus root of 3, right? So 0 comma plus or minus 3. You can separate these to be into two brackets, one with a positive, one with a negative. Okay, what am I trying to say? What I'm saying is positive 3, the other one to be 0 comma negative 3. Then for the vertices, we'll go for a value of a, and the value of a in this case was found to be what? Plus or minus root of 6. So that would be 0 plus or minus root of what? 6. So I'm just reminding you the basics that we already did under the basics, right? Now the key takeaway in this case is this. So don't forget what we found. The foci, we found 0 plus or minus 3. The vertices, which are closer, 0 plus or minus root of 6. Okay, Now of course it gave you an equation for finding the asymptotes. Okay, we said when you're talking about the hyperbola, it has got two asymptotes that don't cut it at any point. Okay, so what was the equation for finding the asymptotes? Okay, so the equation was, if we're talking about the case where it is along the y-axis, the equation was given as y is equal to plus or minus. So in this case, the vertices, which are represented by a smaller value, which is c, in fact that is a, and then c. So in this case we're going to have root of 6 over root of 3. So we find that b is taking part. Okay, and then for our a squared, which is root of 6, right, in terms of our a, so a over b gives us the equation for the asymptotes. So plus or minus root of 6 over 3. Now the key important question that we need to answer is, how do we convert what we have? How do we convert what we have in the form of y minus k and of course x minus h, which is the form that we have? Okay, let me not forget about the equation of asymptotes. Let me just write it there, plus or minus the root of 6 over the root of 3. Okay, so don't forget if it's plus or minus the value of your a over your value of your b. So let's now compare this to that form. The equation that I used to get the foci and vertices was in the form of x prime over 6. In fact, we started with y. So y prime over 6 minus, of course that is squared, x prime squared over 3 is equal to a 1. This is the form of equation that we've moved with. Now I want to create the relationship that we have between these two and help us determine the new foci and the vertices based on the new form of the equation. So what relationship are you able to see? So y prime is equal to y minus 3, right? So if you try to make y the subject of a formula, what are you going to end up? You're going to end with y prime plus the 3. Okay, so the y value is going to be affected by an addition of a 3. Okay, so that part, the foci is going to become plus or minus 6. Okay, and then the vertices are going to become 0 comma plus or minus root of 6, which is supposed to be added by 3. So 3 plus or minus root of 6. Okay, I think it would be fair as well to mention that for the top part as well, which is plus or minus 3, we are adding the 3 to it as well. So 3 plus or minus 3, which of course will give us two values there. One is going to be 0 comma 0, and then one is going to be 0 comma 6 for the foci. And then this other one, we don't have to go as far as using a calculator here to find the root of 6. Not necessary. What's important is you get the idea there. You can split it, one with a positive, one with minus. Okay, so that's what you get for the foci and the vertices. And of course the same idea can be applied to the asymptotes as well. Okay, but basically this is what you needed to know to create the relationship between the the old form of equation and the new form of equation. Something very, very basic and simple. Okay, so now pause the video now. Convert this form of equation into the new form as well. Convert it into the basic form. After you convert it to the basic form, use the x, y, and the y prime to help you find the foci and the vertices, and then after that take it back to this form to help you find back the new foci and the new vertices after translation. Okay, so hopefully you've done that already. Hopefully you've paused the video and you've tried. Aye. So I just wanted to let you know to say we have a longer video to this topic. The video also includes questions on conic sections. Okay, so this story sheet that you're seeing here, solutions are provided too, and then more questions on other topics covered, including the ones that have been covered in this video. Parameterization, power coordinates, and every concept of conic section is fully covered. Okay, so just head over to Hyperbola on our site. Links are provided for in the description below to build confidence and just get out of this simple topic. Alright, so we're going to talk about rotation of axes. So up until this point, we've not discussed a form where we can have a product of x and y in the equation of the conic sections. So we use rotation to actually deal with that. Okay, and okay, so we talked about translation previously, which involves studying a conic section away from the origin, where you come up with the new coordinates about the new point. And then we came up with a new form where we said, for example, when you're looking at a parabola, instead of looking at an equation in not necessarily a parabola, so for example, if you're looking at an ellipse with that form of an equation, what you can actually do is in the new form we said it can be expressed as x minus h squared over a squared plus, and then y minus k squared over b squared. I showed you how to move from that form to this form, and all that went well. Okay, now today I don't know when you're watching this, but in this video basically we're going to talk about rotation of axes. So basically, how do we rotate? So by that, what we're trying to talk about is we are rotating the axes. So if you've got x and y, why do I like putting x on top? So y and the x, this is the original x or y plane. Okay, so what happens if you rotate it counterclockwise or unclockwise, maybe by a certain magnitude of an angle this way? So if you rotate the x y plane, it's going to be like this, and then you do the same and rotate the y by the same magnitude. Okay, then you have it there. Okay, so this becomes your new y and then your new x there. And so let's picture you had maybe a parabola along the using the original coordinates. Maybe it was like this. So when you rotate it by that same magnitude, the fact that it's along the y-axis like this, if you rotate it, it's equal going to be the same, but it would be in the new coordinate system. Okay, so that's basically what rotation is. Okay, so I've shown you now the the practical. Let's get to the theory now, where we perform calculations and see what we can do. So the equations that we're going to use, let me put for you the equations we're going to be using to create a relationship between the x and the x prime and the y prime as well. So our x is going to be given as x prime cosine of alpha minus y prime sine of alpha. The only secret remembering formulas, of course I do give you some hints where it's necessary, but the biggest secret is practice. There's no way you're going to remember all these formulas and the conic sections by just watching the videos, going for lectures, and yet you don't ever solve questions. So we've introduced now a case where we are going to add a lot of PDF questions on the site that will allow you to practice, and then we're also going to add some PDF solutions for references to just ensure that you do a lot of practice. So these are the two equations that are going to be very, very cardinal. Okay, and of course there is going to be a form where you make x prime the subject and whatnot, but we're going to work more with these ones. Okay, so let me just give you the other formulas as well. X prime is equal to x cosine of alpha plus y sine of alpha, and then your y prime is equal to negative x sine of alpha plus y cosine of alpha. So these are the equations we're going to work with. Okay, now straight away we'll look at an example which is going to have, I said rotation helps us do away with the term x, y, right? Okay, and so there we are. So we have been given 2xy is equal to 9. So we are told the x and the y axes are rotated through an angle of pi over 4. Radian is about the origin. Find an equation for the hyperbola in the new coordinates. Okay, so we have to find the equation of the hyperbola in the new coordinates after rotating it by that magnitude. Okay, so let's just do that. So the very first step that we need to work with is we need to find the angle. Remember the formulas that I gave you. Our x is equal to x prime cosine of alpha minus y prime sine of alpha. And then for the other one as well, starts with x prime, except it's like the opposite. So everything else is the opposite. I think that's what can help you. Okay, so you start with, if you can remember one, you can easily remember the other one. X prime cosine alpha minus y prime sine alpha. This will be maintained, and then this will be the opposite, including the signs will be the opposite. So let's do a simple exercise and try to remember the formula. Don't look at what you've written. Okay, so a simple exercise was x is equal to x prime. It was cosine first of all alpha. Is it cosine? Yeah. Cosine alpha minus y prime sine of what? Alpha. Now for the second one, y, x prime is maintained, then everything will be the opposite. So we are going to have sine of alpha. The sine will also be opposite, and then y prime will be maintained, but it will be cosine alpha. Okay, so you can do that simple exercise every time that you're solving this question to just help you recall. Okay, so we've been given the angle alpha. We're told alpha is equal to pi over 4. So we don't have to find the angle like I said. We just have to go and substitute into the equations that we have. So for our x is going to be equal to our x prime cosine pi over 4 minus y prime sine pi over 4. Okay, so that's the first step there. And then of course, as you might guess, we have to now do the same for y. X prime sine of pi over 4, and then minus y prime cosine of pi over 4. So I can see there's repetition here. There's no need of us to complicate things. We can just go on and just simplify. So if you don't understand radians, don't worry, I'll still assist you. So cosine pi over 4, put 180. If you want to think of it in radians, wherever it's pi, put your 180 and then over 4. So if you divide 4 into the 180, how many times is that? So that's 45. So in short, we're talking about angle cos 45, which is coming from a special triangle and whatnot. So what is cosine of 45? That's as simple as 1 over root of 2. Okay, 1 over root of 2. So in this special triangle of ours, we understand that we've got 45, 45 or pi over 4. Okay, and then we've got a 90 on top. We've got 1 there, and then the hypotenuse is root of 2. So if you use SOHCAHTOA for sine opposite of hypotenuse, you're going to get 1 over root of 2, and for cosine as well, you get the same. So this is a case where we know that sine and cosine 45 are the same. So we can just substitute that. So we are going to have x prime, cosine pi over 4 I've said is 1 over root of 2. So when you multiply x prime with 1 over root of 2, it's the same as just over root of 2, and then minus y prime as well over root of 2, since we're multiplying by 1 over root of 2. Okay, which you can actually just now combine the denominator since it's the same. So you can just say over root of 2. Do the same for the other one. So you're going to have, so here the sign is supposed to be positive, I beg your pardon. Okay, so we're going to have x prime over root of 2 as well, plus y prime over root of 2. We can also do the same, combine the, come up with a common denominator, which is just the same. Okay, so now we've simplified, we've expressed our x in terms of x prime and the y prime. Okay, that's the first step that we needed to make. Okay, now after you've done that, you just have to go back to the equation that we have, the equation that we were given, and it's very simple at this point. You just substitute now. While there's x, you put what we found. So we're going to have x prime minus y prime over root of 2, and then for y we have x prime plus y prime over root of 2 as well. Okay, then this is all equal to our 9. Okay, can we simplify this now? Sorry. Now that we've substituted, we can actually go on and simplify. Okay, so don't forget about 2, which is outside. So let's just multiply what is inside the brackets. X prime multiplied by x prime, that would be x prime squared, right? So x prime squared, and then minus times that. So this is actually a difference of 2 squares, so it's just going to be x squared and y prime squared. So the middle part is going to subtract. If you want, you can go on and show it. I don't have to show that to you. I believe you know what the difference of 2 squares is. If you want to try out x prime multiplied by y prime, okay, you'll see that you're going to get what I've written there. And then on the bottom, root of 2 multiplied by root of 2 was aside. Whenever I'm multiplying the square root by the square root, it will disappear, so we remain with a 2. And then this is equal to a 9. The 2 would divide, and then you remain with x prime squared minus y prime squared being equal to a 9. At this point now, to express it in the form of a hyperbola, you want to have a 1 on the right. So divide by 9, divide by 9, divided by 9. So you have x prime squared over a 9 minus y prime squared over a 9 is equal to a 1. Okay, so you have it now in that form. Okay, so you've now found the equation for the hyperbola in the form that we wanted in the new coordinates. Okay, and there we are. Can we give you a rough sketch of it? I already showed you what we mean by rotation. So if you've got a protractor, you can actually measure the angle 45. So 45 is the half of that. Okay, so do the same as well. I don't think my angles are accurate. So this one is going to be, this is our y, that is our x. So this is going to be now our new x and our new y. So the question is, if you look at what we have in this kind of an equation, is it along the x or it's along the y? So you look at what you've started with. So we started with x, okay, and then subtracting with y, so it's going to be along the x-axis. How does the hyperbola come out? So these are parabolas that are kind of like opposite, facing in opposite directions. So since it's going to be along the x coordinate, remember this angle should be, we've rotated it by pi over 445, so it's going to be something like this. Let me draw it using a black. Okay, and they did in this side as well. Okay, so that's our hyperbola rough sketch. We haven't found the foci, we haven't indicated the vertices values as well. Okay, so I hope that has given you an idea of what we've actually done. Now, a simple exercise for you. I love it when people take part. Okay, so it's been a lot of videos since we talked about the equations of a hyperbola. So now I have given you an equation now. Okay, this is the equation that we have. So I want you now to, in the same new coordinates that we have, I want you to find the foci, the vertices, and the center for this hyperbola. Okay, so feel free to pause the video and just try to do that as a simple exercise. Okay, now I want to look at another form of a question. I want to look at another form of the question about rotation. This is now a case where they have not given us an angle, but again we are still seeing that we still need to eliminate the x and the y, and also be able to identify the conic section, because if you look at this equation, we can't identify the conic section that we are talking about, so we have to find the angle theta and then also identify the conic section. So there's a new concept now, finding the angle theta, which we haven't talked about up until this timeline in the video. So let's just do that. So the way we find the angle theta is in two ways. You can either be using the cosine 2 alpha, this is a double angle, a minus c over b, or you can actually use tan 2 alpha is equal to b over a minus c. So now some of you are already asking the question, what do the letters or what do the constants a, b, and c represent? So the assumption is every single time we're going to be starting with x squared, right? So our a represents a coefficient of x squared, in this case a 2, and then our b represents the part that is attached to the product, and then our c represents the coefficient of the y squared term. Okay, so just to give you a bit of some more detail, if I was to write a prime x prime squared plus, or even I'm just writing a demo of xy or not. So let's say how I have a x squared plus bxy plus cy squared, and then d would be the part attached to the x and e would be the part attached to the y, and then the constant would be f. So the ones that we are interested in are the first three: a, the coefficient of x squared; b, the coefficient of the product, which is the term that we're eliminating; and then c is the coefficient of y squared. Okay, so what do we do now? So let's now handle the question that is at hand. So we first of all need to find the angle based on the values that we have So I've said a is the coefficient of x squared, and then b is the coefficient of the product, and then c is the coefficient of y squared. Okay, so let's use the tan. So tan to alpha is equal to, okay, so what did we say? We said it's b and then a minus c, right? So our b is what? Root of 3. Our a is 2, our c is a 1, so we'll just find the 1, so end up with root of 3. Okay, so to find the angle alpha, what do we do? So we can find the tan inverse of root of 3. Tan inverse of root of 3. So assuming calculators are not allowed, if you assume calculators are not allowed, and then you look at just look at the special triangle, 30-60 triangle, that's why we find the root of 3. Okay, so you know from that triangle we've got the 30 and the 60. The 30, which if you convert to the radians, gives you what? Pi over 6. Pi over 6, and then you also have pi over 3, which is your 60. Okay, so sine 30, which is pi over 6, is, so Katoa tells us, so I don't want to teach you trigonometry, but you can actually request access to the math course. We enroll you for free, and then you can actually go through the special triangles and whatnot. So I believe you understand that's going to be, the opposite is going to be 1, the hypotenuse is going to be a 2, the adjacent side is going to be a root of 3. So you want to ask yourself, what value of tan of what angle x gives me root of 3 over 1? Now SOHCAHTOA comes, the tangent comes at the far end of SOHCAHTOA, which implies the opposite over the adjacent. So what angle is opposite to root of 3? Okay, and then adjacent to 1. What angle is opposite to root of 3? So it's actually pi over 3, right? It's opposite to root of 3, and yeah. So you can actually use a calculator to find that. Okay, so pi over 3, and then you can divide by 2 both sides. Your alpha is going to be pi over 6 after dividing by 2. Okay, so we found our theta, or our alpha, sorry, to be pi over 6. If you've forgotten the formula, it's actually tan 2 alpha is equal to your b over a minus c. If you use cosine 2 alpha, you actually swap a minus c over b. So now that you've got the angle, this is similar now to the previous question that we had, because we were given the angle and the equation, and whenever you do have the angle and the equation, the principle is very simple. Just remember the equations. You have to find the value of x in the new x coordinates and the y as well in the new x and y coordinates. So we said the formula is x is equal to x prime cosine alpha minus y prime sine of alpha, right? And then for y, what was it? So we said x prime sine alpha, the sign was opposite, y prime maintained, again it's opposite there, cosine alpha. So what do you want to do now? Just substitute in the equations. So if I'm to substitute in the first one, so feel free to pause the video and just try to substitute and then see what you're going to find. After you find that, substitute back in that equation and see what you're going to end up with. Okay, so after we've paused the video, so x prime cosine of the angle pi over 6 minus y prime sine of pi over 6. Okay, now I've already made a comment. Pi over 6 is equal to 30 degrees. Okay, so you can, if you're thinking in degrees, you can think of that. So what's cosine of 30? That's root 3 over 2. So for the first part, we're going to have x prime multiplied by root 3 over 2 minus y prime sine pi over 6 times 30 is 1 over 2. So we're just going to multiply by 1 over 2. Okay. We'll do the same, we'll substitute in the one below. So x prime sine of that is again 1 over 2 plus y prime. That's cosine of the angle again is just root 3 over 2, which will give us x prime over 2 plus that's going to be y prime root of 3 over 2. Okay, so I can actually now say my x is equal to x prime root of 3 over 2 minus y prime over 2, and then my y is equal to x prime over 2 plus y prime root of 3 over 2 there. Okay, so after this point, now what do we do? Now that we found the x and we've expressed our x and the y in the form of the new coordinates, we can substitute in the equation. So first of all, we have 2x squared. So our x is this. So we're going to have x prime root of 3 over 2 minus y prime over 2, and then this is squared plus root 3 multiplied by xy. Our x is x prime root of 3 over 2 minus y prime over 2, and then our y is x prime over 2 plus y prime root 3 over 2, and then after that we have plus y squared. So plus y squared, our y is x prime over 2 plus y prime root 3 over 2 squared, and then minus a constant 10. This is equal to 0. So we've substituted now the x and the y values in that equation. So if you feel tired, feel free to pause the video because you need to get this. This is very simple. The steps are very basic. Just find the angle using a formula, express the x and the y in the new x, y prime coordinates, and then substitute in that equation. And all you need after that is just to simplify now. Okay, so just feel free to pause the video and just try to simplify this on your own. This is basic square, so you just multiply that brackets by itself twice, and then you do the same for this one, you do the same for this one, and then just simplify. Okay, so if you look at what we have here, so what can we do to make things faster and easier for ourselves? So we have x prime root of 3 over 2 minus y prime 2, so multiplying by itself. So the first part, if you multiply this by itself, we're going to have x prime squared. Root 3 by root 3 are just going to give us a 3, and then 2 multiplied by itself 2 is going to give us a 4, right? Okay, so that's when you multiply this by itself. So x prime multiplied by root 3 gives us that, and then this part multiplied by that part, what is it going to give us? So that's what we need to write now. just move this a little bit. So if we multiply that by that, we're going to end up with x prime, y prime, root of 3. On top, on the bottom, we're going to have 2 times 2, which is still going to be a 4. And then again, on the next step as well, if multiplied by itself, if we multiply now, we've now moved to the part where we're now multiplying by that part with this part. So it will give us the same, it will be repetitive, which implies it's going to give us 2. Okay. And then now here on this part, if you multiply it by itself, it's going to be positive y prime squared over 4. Okay, this was in the bracket squared, now there is a 2 which is outside there. Okay. So we can proceed in the similar manner, root 3, and then try to simplify the other parts as well. Okay, this part multiply by that, again you get this part multiplied by that part. Okay, so I've given an example on how you do this on the first part. I believe you are able to simplify the other parts on your own. So 2 there, 1, 2 there, 2, 2 there, 2, 2 there, 2. So you end up with the coefficient is remaining there is 3 over 2, and then x prime squared. The 2 can divide, so that you only remain with root of 3, and then x prime y prime. This part you've got y prime squared over 2. Okay, so y prime squared over 2, and then simplify this part. Okay, by the way, pause the video and try to simplify and then I've simplified on my paper to avoid just doing a lot of writing and talking. So everything else I'm ending up with 3 root of 3 over 4 x prime y minus root 3 over 4 x y y prime minus 3 over 4 y prime squared plus 1 over 4. Okay, 1 over 4 x prime squared plus root of 3 over 2 x prime y prime plus 3 over 4 y prime squared minus 10 is equal to 0. So remember, there were just 3 steps that we've done. Don't forget about what we're looking at right now. So this is just simplifying, trying to take it in a simpler form that we can. Okay, so now at this point the question is, are you able to identify the like terms? Are you able to identify the like terms? So first of all, if you try to observe the ones that are having x prime squared, there's this one. Whichever one is having x prime squared, so it's this one. So you're now going to add 3 over 2 plus 1 over 4. Okay, so common denominator there of course is a 4. So 2 into a 4, 2, that's 6, plus 1, right, is mathematics okay there. So we've got 3 over 2 there, attached to x prime. Which other one is attached? So there is the 1 over 4, which I've identified. Now I made an omission somewhere there. Yeah, there's an omission. Okay, so on my paper is this value that I omitted here. So y prime, after half y prime squared, there is 3 over 4 x prime squared. Sorry for that. Okay, so what we are going to end up adding, 3 over 2 plus 3 over 4 plus 1 over 4. Okay, so those are the ones that we are adding together. And so for and then 2 there, it's just like 2, 6, 4 there, it's 1, and times 3, it's just going to be a 3, and then 4 there, it's 1, so that's going to be 10 over 4, which if you divide by the 2, you're going to end up with 5 over 2 x prime squared. So we've dealt away with the ones that are attached to x prime squared. Okay, and then we can now look at the ones that are having the, let's look at the other like terms now. We've got the ones attached to x prime and y prime. Okay, and which is, the other one is where is the other one? The other one is here. Okay, we've got this one there, and then there's also another one right there, and then there's another one right there. Okay, so let's try to write them down. So for the constants, we've got minus root of 3 plus 3 root 3 over 4 minus root 3 over 4, and then we've got plus root 3 over 2. Okay, common denominator 4. 1 into 4 is 4, so we're going to have negative 4 root 3, and then plus 3 root 3 minus root 3, and then 2 into 4 is 2, so we're going to have 2 root 3. Okay, so if you look at negative 4 plus 3 root 3, that's going to be a negative root 3, and then minus root 3 plus 2 root 3, so this is going to be a negative 2 root 3 plus 2 root 3, which is going to be a 0 over 4. Okay, so that part is going to be eliminated completely. This part, that part, that part, and that part, which was our goal. Okay, wanted to eliminate the xy part. So what remains now is the y prime squared over 2 minus 3 over 4 y prime squared, and then plus 3 over 4 y prime squared, which is our interest. Okay, common denominator 4. 2 into 4 is 2, so 2y prime squared minus 3 y prime squared plus 3. So with the negative 3 and the 3 will subtract. You remain with 2. 2 there it's 1, 2 there it's 2, so y prime squared over a 2 is equal to, this constant can be on the other side, it becomes a 10. Okay, so at this point, what do we have? I want to identify the conic section, so we want to have a 1 remain on the other side, so we can divide by a 10, 10, 10, 10. So for first part, 5 there it's 1, 5 there it's 2, so 2 times 2, 4, so we have x prime squared over 4 plus y prime squared over 20 is equal to 1. Now what kind of a conic section is this when you see an addition on the left? Okay, so that's an ellipse. If it's a subtraction, it's a hyperbola. Okay, so this is an ellipse. So another exercise, pause the video right away. I want you to find the foci, the center, the vertices of this ellipse. Okay. Okay, so the fact that the y I've given you the fact that we've got a bigger denominator on the y part. What does it imply? So it tells us the major axis is going to be along what? The y-axis. Okay, I've given you a hint there. Okay, so the other go, let's find now we know the ellipse is going to be in the form of x squared over a squared plus y squared over b squared is equal to 1. So we can find our a squared. So our a squared is equal to 4. Our a becomes plus or minus root of what? Root of 4 is 2. And then our b squared is equal to 20. So our b becomes plus or minus 20. Root of 20, that is. Okay. The other thing that is cardinal, b is just a representative. Okay. So there is a constant c, right? So c squared does relate to b squared minus a squared. Okay. In other terms, our b squared is addition of c squared and what? C squared and a squared. Okay, this is for a case for an ellipse. When it comes to the other case, it's actually c squared is equal to a squared minus b squared, or b squared minus c. B squared is equal to c squared minus a squared, but this is a different case. Okay, so now at this point I hope you've written down the coordinates. So our c squared becomes, our b squared is 4, our a squared is, what do I said? My b squared is 20, our a squared is 4. So our c squared becomes 16. So our c, therefore, it's plus or minus root of 16, which is a 4. Okay. Now, I always give you some hints that can help you deal with certain things like this. When you look at an ellipse, where is the foci? The foci lies within the ellipse itself. The vertices are outwards, so the bigger value will go for the vertices. Okay, so which one is bigger between c and a? C is bigger, so this is going to represent the vertices, right? Okay, is it true? Is it true? Are you doubting? Are we on the same page? Okay, so the fact that this is actually along the y-axis is one point that you should actually keep in mind. Okay, very, very important. So our c is there. What's the value of b? The value of b is also a value that you need to be mindful. Root of 20. What do you expect to be the value of root of 20? Approximately what? 4 is 16, so it's something like 4 point something for b. So which actually makes it to be a bigger value, right? So if you try to simplify it in terms of a SAD, that would be plus or minus. Root of 20 can be a product of 4 and 5. So you end up with plus or minus 2 root of 5, which is actually a bigger value. So that one is going to take now the longer one. Okay, it's longer than the c because this is approximately greater than 4. Okay, so for an ellipse, you've got 4 vertices, so it's important that you determine which one is bigger. So the biggest value is for b in this case. Remember, I did mention to say that the fact that we've got a greater denominator for y, it implies this is going to be in this form. So the biggest value we have is the root of 20, or 2 root of 5. So that's going to present the vertices, 2 root of 5, and then 2 root of 5 as well. So that's the y coordinate. Okay, assuming this is along the x or y plane. Okay, of course in the new coordinate system. And then of course if you look at the other value of the vertices, which of course the smallest value is going to be for the foci. So therefore, no, not the smallest value is not going to be for the foci. The smallest value is going to be the vertices along the x-axis. Okay, so which is represented by our A, right? So this part is going to represent the vertices, so -2 and 2, and then the foci, which is going to be inside part, the y values as well are going to be presented by the 4, so 4 and -4. So in summary, when you're trying to deal with an ellipse, if you've got your A, B and C, the key part is to determine which one is the biggest value that represent the major axis. In a case where, for example, this one is actually it's along the y-axis, the bigger value was the root of 20, so which has ended up being the major axis, which is along the y-axis. So therefore the coordinate for our vertices are plus or minus, which is actually the y coordinates, so plus or minus root of 20 or 2 root of 5. These are two, you can split them, one with a positive, one with a negative, and then the other set is plus or minus 2 of 0, which you can also split, giving you 4 vertices. And then for the foci, which was our f value, we've got 0, 4 and 0, -4 because it's along the y-axis. Okay, so all these are given in the new set of what? In the new set of the xy plane that was rotated. Okay, the new xy prime coordinates. So there may be a question where they want you to go as far as proceeding and determining the vertices and the foci in terms of the x and the y itself. So because remember, what we've used here is we've used the x prime and the y prime, right? So you can go as far as now using the original coordinates. Okay, and how do you do that? So this is now where you go back to the form of the equation again, where we said our x is equal to x prime cosine alpha minus y prime sine alpha. Okay, so if you look at, I can give you one example. If you look at the foci, our foci of 0, 4, for us to find the one for the x, so for us to find the x value there, we have to use this formula. Okay, so our foci in the x y original is going to be, our x prime is 0. Remember we were dealing with x y prime, so this is x prime y prime. So if we're taking it back to the original form, we use that equation. So we're going to have the x prime, which is 0, of course 0 multiplied by whatever we're going to have, the cosine of the angle that we found. What was the angle? If you took note of it, the angle was pi over 6, which is a 30. So that's just a 0, and then this part minus, okay, minus what? Minus y prime, which is a 4, and then sine alpha, sine 30 is what? Half. Okay, that's for x coordinate, comma y. Now for y, how do you go about it? So you also have to write down the formula again for the y part. So y is equal to x prime sine alpha plus y prime cosine alpha. So to find the y coordinate, we equally have to substitute in that equation. Okay, and how do we do that? So what is our x prime? X in this case again still remains a 0, and then sine pi over 6, which is still half, will still be a 0. Now that part plus y prime, which is a 4, and then cosine the angle, cosine that, So cosine 30 is what? Root 3 over 2. So that's how you're going to find the first coordinate of a foci, 0, 4. Okay, the same principle applies to the other coordinate. So this part is going to be negative 2, comma 2 there, 2, that's 1, so it will be root 3. So that's going to be the first coordinate of a foci in the new set of what? In the new set of coordinates. Okay, negative 2 comma root of 3. So you apply the same to vertices as well using these formulas. Okay, these questions are rare, but it's possible they can ask you those questions. So if you are very familiar with those equations, it's very simple for you to handle this. Okay, so now your exercise is to pause the video and go as far as converting all the vertices to that form. Okay, so the values that you should end up with for the other foci value, 0, negative 4, if you substitute in that formula, the coordinate is going to become what? 2, negative 2 root 3. And then for the vertices, if you convert the first one, which is 0, 2 root 5, positive part is going to be negative root of 5, root of 15. Then you get the negative 1, 0, negative 2 root of 5. It's going to be root of 5, negative root of 15. Okay, so basically this is what you basically do when it comes to rotation. The basic idea is to do away with a value of x and y. Okay, so now I'm going to attach a PDF with practice questions about translation and rotation, and do well to practice them before we proceed now to the simpler concept of a discriminant test, which can also help us deal with x, and which can help us identify the conic section without actually going as far as dealing with x and the y. Okay, so thank you very much for watching. I hope you've learned one or two things. So I just wanted to let you know to say we have a longer video to this topic. The video also includes questions on conic sections. Okay, so this story sheet that you're seeing here, solutions are provided too, and then more questions on all the topics covered, including the ones that have been covered in this video. Parameterization, power coordinates, and every concept of conic section is fully covered. Okay, so just head over to Hyperbola on our site. Links are provided for in the description below to build confidence and just get out of this simple topic. Alright, so we've talked about the rotation of axes. Now I want to talk about the discriminant test. So this is another way, instead of actually eliminating the x and y term, in a case where they ask you to identify the conic section, you can use a discriminant test to just help you do that. So the concept is very simple. I've already explained to you that if you have an equation in the form of ax squared plus bxy plus cy squared and plus. The key idea is the coefficient of x squared is a, coefficient of the product is b, and then of y squared is c. So we can actually use these to help us test. So the formula for the discriminant test is b squared minus 4ac. I think this is something familiar. If you remember quadratics, the quadratic formula, it would be b squared minus 4ac. So just capitalize that and you have a formula for yourself. Okay, so now what is the key here? When it's equal to 0, it's a parabola. Okay, when it's less than 0, it's an ellipse, and when it's greater, it's a hyperbola. Hyper means bigger, so in this case we use that to help us remember. The hyperbola will be greater than 0, and then when it's equal to 0, it's a parabola. The ellipse will be less than 0. Okay, so I hope you got that. So pause the video. Given x squared plus xy plus y squared, and then minus 1 is equal to 0. Feel free to pause the video and perform a discriminant test. Is it an ellipse? Is it a parabola? Is it a hyperbola? Okay, so the concept is very simple. B squared minus 4ac. Okay, so I told you to say the coefficient of x squared is your a. In this case it's a 1, and then your b is the coefficient of the product, so a, b, and your c is the coefficient of y squared. So our b is 1, so 1 squared minus 4. Our a is 1 as well, our c is 1 as well. So we have 1 minus 4, which is a minus 3. So is minus 3 greater or less than 0? So this is less than 0, not greater, less than 0. So since negative 3 is less than 0, sorry, that implies that this is what? This is an ellipse. Okay. Okay, try another one here. I've got another one for you. xy minus y squared minus 5y plus 1 is equal to 0. Is it a hyperbola, an ellipse, or what? Okay, so you want to arrange it in an order that it actually you don't confuse yourself. So the fact that we don't have x squared, what does that mean here? Okay, so identify your a. Your a is the coefficient of x squared. We don't have any here, so it implies that's got a 0. So 0. Our b is the coefficient of the xy, which is a 1, and then our c is the coefficient of y squared, which is a negative 1 in this case. Okay, do it to substitute. B squared minus 4ac. Your b is a 1, 4, your a is a 0, your c is a negative 1, so it doesn't matter. You end up with just the 1 minus 0, which is just the 1. Now a 1 is of course what? A 1 is greater than 0, so this is a hyperbola. A hyperbola. So a hyperbola is greater than 0. And then of course, lastly, 3x squared minus 6xy plus 3y squared plus 2x minus 7. Do the same. B squared minus 4ac. Your b is the coefficient of xy, so that's a minus 6. And then your a is the coefficient of x squared, which is a 3. And then your c is the coefficient of y squared, which is a 3 as well. And then you end up with 36. 3 times 3 is 9, 9 times 4 is 36. So you end up with a 0. Okay. Or 4 times 3 is 12, times 3 is 36, so 0. So this is a parabola. Parabola. Okay, so basically we've done this discriminant test, and that's where we end. Alright, so in this video we just want to explain what eccentricity is. Alright, so eccentricity is just a number associated with each conic section, and it reveals what conic section you're talking about. Literally I can just say eccentricity is just I think the measure of how much a shape has deviated from being circular. Okay, so how much it has deviated from being circular. Okay, so if we look at the conic sections that we've already discussed so far, we've talked about a circle, we've talked about an ellipse, we've talked about a parabola, and then we've also talked about a parabola. So which one do you think has deviated very much from a circle? So of course, just from the fact that we're saying how much a shape has deviated from being circular, this actually tells us to say a circle has not deviated in any way from being a circle. So the eccentricity of a circle is just a 0. The one that is closest to being circular among all these other shapes is an ellipse. So an ellipse, as we might expect, is supposed to have a value less than a 1. Okay, and then the one that has deviated the most from being circular is a hyperbola. So it has got an eccentricity value greater than 1, and then for a parabola it's just equal to a 1. Okay, I'll explain why. So that being said, so there's no need of you to ever calculate the eccentricity of a circle and a parabola because they are known. Okay, that's 0. For a parabola it's a 1. Now how do we calculate the eccentricity of the other two, a hyperbola and an ellipse? Okay, I've already given you an hint to say for an ellipse our value is always supposed to be less than a 1. For a hyperbola it's always supposed to be greater than a 1. The formula for eccentricity is just given by c over a. Okay, where in terms of a hyperbola, if I was to give you a hyperbola here like that, the distance from the center to a vertex, okay, is a, and then the distance from the center again to a focus is c. Okay, so that's what we're talking about in terms of a hyperbola. That's what the c and the a are representing. So c is representing a distance from the center to the focus, and then a, the distance from the center to the vertex. Okay, some textbooks might define the eccentricity to be the distance between the foci, meaning that you measure from one focus to the other, okay, which of course would become 2c, and then also the distance between the vertices. So that would give us 2c over 2a, which will still be c over a. Okay, so I've established a is c over a. Now the formula of a hyperbola, we already know to say it's actually, whenever we're talking about a hyperbola, if you go back to the original definition of a hyperbola, you see that it's actually a difference, right? Okay, you measure distances, the difference between the distances to a foci is a constant. Okay, so how does that look? So you've got a foci somewhere there and a foci somewhere there. Get any point on the hyperbola like that, and then measure its distance to the two foci, or the two focus, which is foci to a foci. The difference there is a constant. So the formula is x squared over a squared and then minus y squared over b squared. This is in a case where it is along the x-axis. Okay, that is our formula there. So that being mentioned, you also need to know that eccentricity, in this case c over a, how do we find the c for the hyperbola? It's actually going to be, so a secret here is just change the sign if you are confused. So it's going to be a summation of a squared plus b squared over a. And then for the ellipse, it's a different scenario. Since it's supposed to be less than 1, it's going to be a squared minus b squared, just like we do. Okay, so c over a, that's how we find the eccentricity of an ellipse. Okay, so I've given you a lot of tips that can help you remember the formulas for both of these. Let me leave them out there for you. You know the equation of the basic form of an ellipse is going to be in terms of addition, right? Okay, so obviously when it comes to its eccentricity, you change sign there. Okay, that being said, what else have I not mentioned about these? Yeah, I haven't explained to you why so we can also actually define the eccentricity in terms of the distance to the focus, okay, divided by the distance to the directrix. Okay, so in a case of a parabola, we understand that there's a line what we call directrix, and then there's an inner point that we call the focus. The distance from any point on the parabola to the focus and also the directrix is actually the distance is actually the same, so they are equal. So you would actually understand why the eccentricity of a parabola is a 1. Okay, I think let's look at some few examples here we see. Okay, assume you're given 4x, not 4x, let me start with, let's say we have 9x squared. Assume we have 9x squared plus 25y squared is equal to 225. So determine the eccentricity of this shape. To start with, what shape is this? So observe is a summation there. So is it an ellipse? Is it a hyperbola? Whenever you see an addition there. So when you say an addition, just know it's an ellipse because you understand that comes from its definition. Okay, it has got the foci inside of itself. So if you try to measure distance to the foci from any point on the ellipse, call that d1, call that d2, their sum is a constant. Okay, so we're dealing with an ellipse, so we expect that E should be less than a 1. Okay, and therefore want to put it in the form where we've got a 1 on the right. So divide both sides by 225, 225, 225. What do we end up with? So 9 into 25 is how many times? 25. So x squared over 25. 25, it's a 1. 25 into 25 is 9 times. Okay, 9 times. And then that is just equal to 1. So we have our basic form for the ellipse. Okay, so this is greater than the 9, right? So you can have x squared over 5 squared plus y squared over 3 squared. We're just expressing them in terms of squares because that's what the basic formula tells us, right? So we understand that the first part, where there is 5, it's a, and then where there is 3, it's b squared. And of course, most people usually get confused. How do I know which one is a, which one is b? So a is going to be greater than b in a case of an ellipse. Okay, the reason is very, very simple. Okay, when you look at the foci is inside for an ellipse, so that's why b is actually, if you take it in terms of c, that's why you actually find that c is actually smaller. Okay, so therefore our eccentricity here is c over m. Now our c in this case, there's an addition there, so let's put a subtraction. So we're going to have a squared minus b squared over c, sorry, a. Okay, so our a is 5, so 5 squared minus 3 squared over our a, which is a 5. So 5 squared is 25 minus 9, that's 16. So we end up with root of 16 on top, which will give us a 4, and then we've got a 5 down there. So 4 over 5, which is less than 1. That's the eccentricity of that ellipse. Okay, very simple and straightforward, right? Feel free to pause the video and try this very simple one. And as you might guess, this is, what shape is this? Okay, so pause the video and try this one out. So we have x squared over 4 squared minus y squared over 3 squared is equal to 1. So what shape is this? In fact, it's a minus. So this is a hyperbola. Okay, so a parabola is very much deviated from being circular, so the value should be greater than 1. So E is equal to c over a, and then our c, we'll just do the opposite of what we have. So we're going to have a squared plus b squared over a. A squared is 4 squared, 3 squared. over m. So we're going to have 16 plus 9 on top, which will give us 25 over our a is a 4. So we're going to have 5 over 4, which is of course greater than 1. Okay, that's how you handle these two basic questions. Now I've got 3 more questions that I want you to try out. Question 1, we're told locate the vertices of an ellipse of eccentricity 0.8 whose foci lie at the points 0, plus or minus 7. So it's very easy to handle these questions if you know the shapes they're discussing. An ellipse. An ellipse. Okay. So how do I know that this ellipse is longer along the x-axis? Based on the fact that we are told the foci is what? Actually, the foci is actually the y value in this case. Okay. Okay, so in that case, it's supposed to be along the y-axis. Okay, like that. It's supposed to be like this. Okay. So plus or minus 7. So that's a foci, right? So positive 7 and negative 7. Okay, assuming the center is about the origin. Okay, so one there is positive 7, one is negative 7. Okay, what are we told? We are told to locate the vertices of an ellipse of that eccentricity 0.8 whose foci lie at the points 0, plus or minus 7. How do we do it? So the other formula that we should know is eccentricity is given as, what did we say? We said the distance to, in fact there's this other definition. I said the distance between the foci divided by the distance between what? The vertices. Okay, that's another formula that we actually talked about. So distance between the foci, distance between the vertices, it gives you the eccentricity. So eccentricity in this case has been given to be 0.8. Okay, so therefore we've got E is equal to our E is 0.8. Okay, now we've given plus or minus 7, so that 7 is a distance to the foci. Okay, so distance to the foci is 7, and then we don't know the distance to what? The distance to the vertex. Okay, this is the way that I actually put it. So I said when you're looking at an ellipse, C is representing the distance from the center of the ellipse to the foci, and then A, the distance from the center to the vertex. Okay, and that's why in an ellipse you see that the value is actually going to be less than what? Less than 1, because the denominator is greater than the numerator. So try to find x. You're going to have 7 over 0.8. Okay, grab your calculator there and try out this basic question. So you're going to end up with 8.75. Okay, so our focus was just trying to find the vertex along the major axis. So this would be 0 plus or minus 8.75. So implying one would be there, 8.75, one would be down there. Okay, so you've seen that actually picturing the diagram helps you to simplify the question faster and easier. I want to look at this one, find the eccentricity of the hyperbola. So from looking at a similar question, I think now I have some courage and pause the video and try this one out. This one they've specified this is a hyperbola. Eccentricity is given as C over A. I already showed you how to find C. I gave you a hint. Since it's positive, it's negative there, just do something there over C. So that's going to be A squared plus B squared, and you expect it to be greater than 1. Okay, so divide throughout by 144, and yeah, be able to get the answer there. Okay, So feel free to comment out your answer. So the answer that you should actually get for eccentricity here should be 5/4 or simply 1.25. And then the last question here is find the Cartesian equation for a hyperbola centered at the origin, that has the focus at 3, 0 and the line x is equal to 1 as the corresponding directrix. Okay, so this takes us back to the other basic formula that I gave you. I said eccentricity in terms of when you looked at the parabola, what did we say? We said the distance to the focus divided by the distance to the directrix. Okay, so what are we trying to do here? What are we told? Here we are told we need to find the Cartesian equation. So we need to find the equation for this hyperbola. Now we are told centered at the origin, that has a focus. So that's our focus, 3, 0. Okay, and then the line x is equal to 1. So distance to the focus, if you look at this hyperbola, this is the way it is. Distance to the focus has been given. So if you look at it, it's 3, 0, 3, 0. So that implies you've moved. So that would be somewhere maybe there. Okay, 3 units too along the x-axis. So 3, 0. So that would become a distance from the center to the focus. So we may assume if the center is about the origin, that would imply on the other side it would be -3, right? That's what it would imply. So remember, the foci for the hyperbola is beyond the vertices. The vertices are these points. Okay, so therefore the distance side is just 3, and then the distance to the directrix as well, in this case, in this rare case, is actually at x is equal to 1, so which is 1, 0. Okay, so that will imply we have a 1 on the bottom, so giving us an eccentricity of 3. Okay, which now, if you want, we can actually make most of it to help us simplify what we have. Okay, so the formula, on the other hand, we said eccentricity is actually c/a. Okay, we can actually try to make most of that and see what we end up with. So in that case, we'll see that a in this case is equal to a 1. So now let's try to find the missing one, which is b, right? We need to find b. Now the top part we said is c, so c is equal to 3. What did I tell you? I told you to say e is equal to c/a, and then c is, what are we dealing with? Hyperbola. What's the basic form of equation? Is it minus or negative? So this is a negative. Okay, so therefore we're going to have an addition there. So c is equal to the root of a squared plus b squared. Our c is 3, our a is 1, our b is what we don't know. So square both sides so that the squared can disappear on the right. You have 9 minus 1 is equal to b squared, and then b squared becomes 8, right? So b squared becomes 8. Okay, so let's not forget that our a is 1. So if we were to substitute for a squared, that's going to be a 1. And then for b squared we found 8. So we'll have 8 there. And then of course dividing by 1 is just as good as not putting it there. And then y squared over 8 is equal to 1. So that's the equation, Cartesian equation for this hyperbola, based on the concept of the directrix or eccentricity, helping us to find the value of a and b. Okay, so that's it to this video. I hope you've understood what eccentricity is. And if you want to have access to the entire conic section topic, use the link in the description below to access a video either on Patreon, on our site, or YouTube Premium. Thank you very much for watching.